your mobile phones on silent mode or switch it off. Good morning. I request all of you to please stay silent. Students, the dignitaries are on the way. Students, please switch off your mobile phones or put it in a silent mode. I request everyone to rise. Good morning all. I request the dignitaries to grace the dais for the inaugural function. Good morning again. A warm welcome to the inaugural function of the one-day workshop on environment and green energy, PARYAVARAN-2023, jointly organized by Indian National Academy of Engineering, INAE, Bangalore chapter, and Gokula Education Foundation. We will start the inaugural function with Ramaya anthem. I request all to rise for the same. request our Principal Sir, Dr. N.V.R. Naidu, to deliver the welcome address.
Very good morning to all of you. I, on behalf of Bangalore Institute of Technology, and on my behalf, welcome our Honorable Chairman, Dr. M.R. Jairam sir, the Chief Guest of today's workshop. Padma Vibhushan, Dr. V.K. Athreya sir, the Guest of Honor, all the members of the INAE present here and delegates for the one-day workshop on environment and green energy, PARYAVARAN-2023. At Bangalore Institute of Technology, organized by Gokula Education Foundation in partnership with INAE Bangalore chapter. The workshop's main goal is to raise awareness among the students and about sustainability and the harmful effects of climate change. The workshop will feature lectures from well-known speakers as well as student group presentations from different institutions. As a principal of the Sports Institute, it is my privilege to welcome our Chairman, Dr. M.R. Jairam sir, Gokula Education Foundation, the Chief Guest of today's inaugural function. Dr. M.R. Jairam sir is well known for being both an educator and an industrialist. He is also interested in philanthropy and community development. He serves as a Dharmadhikari of Kaivara Kshetra, a place of workshop around 60 kilometers distant from Bangalore. This Kshetra is involved in restoring historic temples in and around Kaivara, offering health care and education to the local people, feeding the hungry on daily basis, organizing yearly mass weddings and engaging in a number of other socially significant activities. As a Dharmadhikari, Dr. M.R. Jairam sir facilitates 4 dhanas of our services to the community, that is Annadana, Abhayadana, Aushadadana and Vidyadana. Sir, we are extremely privileged to have you in this function. I welcome you, sir. I extend a cordial greetings to the today's guest of honor, Padma Vibhushan Dr. V.K. Athreya sir, former scientific advisor to Russian Mantri, former secretary, DRDO, and our honorable member of governing body to this function. Dr. Athreya sir was awarded the Padma Bhushan in the year 2000 by then the President K.R. Narayan. He was bestowed with Padma Vibhushan Award, India's second highest civilian award in 2016. Dr. V.K. Athreya is an excellent support to the Institute. With his valuable input to the governing body, the Institute is able to plan innovative initiatives and significantly benefited by his advice. I welcome you, sir. I wholeheartedly welcome our Honorable Chief Executive, GEF, Engineering and General Sciences, Sri B.S. Ramaprasad sir, an experienced and a knowledgeable person who is working tirelessly in order to keep up the academic standards of the Institute. I welcome you, sir. I welcome Professor S. Gopal Krishnan, President, INAE Bangalore chapter for this function. I also welcome Dr. Pramod Kumar, Associate Professor, Mechanical Engineering, University of Science, Bangalore for this event. It is my honor to welcome today's distinguished speakers, Professor J. Srinivasan, UHR Climate Center, Indian Institute of Science, Bangalore. Dr. S. Dasappa, Chair in Interdisciplinary Center for Energy Research, IAC Bangalore. Professor S. Reswamy, Associate Professor, Center for Climatic Change and Sustainability, Aditya University, Bangalore. It is my pleasure to welcome Professor Pradeep Datta. Professor Pradeep Datta, you certainly he was a jury member. I be the former Vice Chancellor of the Defence Institute, the Pune. I'm very happy to welcome our Chief Finance Officer, Sri G. Ramchandra sir, for this function. I welcome Dr. Pradeep Kumar Dixit, Vice Principal, Dr. Archana, Registrar Academic, Registrar Admin, HODs, faculty, staff and students of our Institute of Technology for this evening. I would like to extend a warm greeting to the attendees from BMS College of Engineering, PS University and INAE Mysore. As we are all aware, today is a momentous day for all engineers as we commemorate democracy. Thank you all.
Thank you, sir. I extend a very warm welcome to our principal, sir, who has been a motivating factor for all our endeavors. I request the dignitaries to light the lamp and inaugurate the workshop. Thank you, sir. Thank you all. I now request our respected Dr. Atre, sir, to deliver his inaugural address.
Good morning. Greetings of the Engineering Day to all of you. And, why this day we celebrated Surya Vishweshwaraya's birthday. If you trace the history of human civilization to about 1,000 years ago, when we started the agriculture and created a geological epoch called Holocene period. Since then, we have been reasonably living in harmony with nature, observing nature, learning from nature, but respecting nature. In the recent times, somehow we don't seem to live in harmony with nature. So much so, somewhere in 1980s, the decade of 1980s, Nobel Prize winning Dutch chemist called Paul Gerson, who was very famous for his ozone hole, and the American limnologist Eugene Stoermark coined a phrase called Anthropocene, age of man, in which anthropocentric and anthropogenic activities had tremendous impact, unfortunately deleterious impact, on the environment. Since then, there have been several committees trying to study what is this anthropocene? Is it really true? Is the human endeavor, especially driven by science and technology, the root cause of what we are facing, what it should be. There have been committees set up. In fact, UNESCO has a committee set up on how should the education be by the middle of this century to face the Anthropocene activity. Some people do believe that the Anthropocene should be traced back to the end of the 18th century, when we had industrial revolution and committed ourselves to fossil fuel. Others have disagreement. There are a number of days. Some people say it will be 12,000 years old when we started agriculture. Some people say it should be 1945 when we dropped the atomic bomb. And all kinds of things going on. Irrespective of what the philosophy of Anthropocene or when the actual Anthropocene is, today's humanity faces several predicaments. We all know, well aware of global warming, receding of glaciers, changing weather patterns, increase in natural disasters, sea level changes inundating the coastal areas, and some cities like Mumbai may be flooded in the next few decades. And we also know what we have done with the so-called exquisite material called plastic, and how we have come to plastic pollution and having dead zones in our oceans. Whether science and technology or the healthcare has improved our longevity or whatever it is, the human population is supposed to reach somewhere about 10 billion by the middle of this century. I propose we have had severe deforestation, reducing not only the biomass, but coming in conflict with other aspects of the other species of evolution, and probably having pandemics like the one we had, perhaps it's going to increase. And some do believe that we are going to have extinction created by this in a much faster way than the nature has done. We have a number of other issues. For example, superamount of aerosol in the stratosphere, interfering with the nitrogen and phosphorus cycle of the atmosphere. I can go on and on talking about what could be the effect of the Anthropocene. So, for the last few years, I have been talking about this. In fact, I was just telling Professor Yashinimos, and I wanted to conduct this seminar about 3 years back when the pandemic interfered with it. The reason is, we don't still appreciate it. The doomsday sayers we tend to think are necessarily exaggerating things and so on. There are people who tend to think we are almost reaching a non-reversible situation. Is it true? If so, the large amount of responsibility is on our generation of the previous generation. So what is the future generation of people who are sitting here going to do? How are we going to tackle this problem? What is that we should do? Our mode of thinking has to become quite different. In fact, Albert Einstein also said, if you have to solve the problems which you have created, our methodology of thinking has to be quite different from the one when we had created this kind of thing. So that is the reason. We must be aware of it. We must recognize that something has to be done. And that has to be done by your generation and your future generations. So I thought it would be quite appropriate, being one of the leading academic institutions in Bangalore. I requested Professor Jayam whether we could, Indian National Academy of Engineering, which finally has to find a engineering solution, and Gokula Educational Trust would conduct this particular seminar on PARYAVARAN every year, hoping that in the years to come, this will be the flag bearer for looking at the environment, at least in the sense of understanding it, appreciating it, and how to look at how to mitigate it. That is the fundamental question of this. We have assembled a few speakers who will talk about this, but it's mostly student-centric. The afternoon session will be student session, And I do hope we are going to come with a solution. What triggered me mostly was about a year back, Times of India produced a magazine called To Serve with Nature. A book which was put together on the world's leading ecologists, environmentalists, people who talk about anthropology. Unfortunately, the book is out of print so quickly. But if you're really interested in this area, you must look at the Friday issue of Times of India, where Srijana Das, who edited this, regularly interviews the world's greatest experts. And there's an interview, a full-page interview on what we are going to do with PARYAVARAN, ecology, and how to get out of this. Very serious problem. Let's not brush under the carpet saying it is doomsday says worse. The world indeed is facing a very serious predicament. Are we going to get out of it? We have no choice but to get out of it. We have no choice but to find the scientific technological solution or finally engineering how to implement those solutions. And the UN report which has just come out, and the red parts of it talks about what this is, whether anthropocene is true or not, but the impact of anthropocene is unbelievable. I'm not going to question it. I do hope by the series of seminars which we are going to hold on September 15th of every year, in the few years to come, we at least will become aware of what this is all about, let alone mitigate it. Thank you.
Thank you, sir. We will do our best to protect the environment. Thank you again. I now request our Honorable Chairman, sir, Dr. M.R. Jairam, sir, to deliver his presidential address.
Surrendering myself to the divine, my respected engineer, Padma Bhushan, Dr. V.K. Athreji, Professor J. Srinivasan, S. Dasappa, Professor S. Goswami, the members of the faculty and students. This is we are remembering the Vishwesvaraya, a great statesman and engineer. He's not only an engineer but a great statesman. On this day, we are talking of environment, which is the whole world is being talking about it. I'm just a humanist, I'm not an engineer or anything like that. I'm just an ordinary humanist. The man was in age, in older times, we don't know the time, we can just say the olden times. They had given a lot of importance to 5 elements. 1, earth. Second is water, third is fire, fourth is air, and fifth is akasha, that is the sky. Now these are the elements which all the civilizations in the world, in times immemorial, have protected them as the greatest asset of all the lives which are in this planet. But they say also that they are the 4 yugas, and this Kali Yuga was the worst times, and this has come all about. And it is being passed also. A number of Kali Yugas have come and gone. And all the time, there has been a destruction during that Kali Yuga. the man becomes a very avaricious man. Everything goes back to human mind. And once he starts using himself for his own selfish ends, all this problems lands. That's what they say. When you look at our times, there is one beautiful story in America, and they said that there was a great rush from east to west to search of gold. Thousands of people, families, left and started searching for gold. They started going, families after families, in search of gold. And in that process, many of them died, nobody bothered. The father died, the wife was going forward, or the husband was going forward, the children were going forward. If anybody else was dead, they were just burying them and going forward. They were not bothered. Their concentration was on gold. Now, I think this is exactly what has happened to our human society. We are now rushing to have that gold. The gold is how to utilize these elements. This is the basic, I think, truth that we are now having. Now the man is now suddenly opened his eyes. Now he says, where are we now getting into? Can we get back this? Trying to balance out all these 5 elements. He is not sure. He doesn't know whether he can do this. But only thing that everybody is talking about is how to contain whatever that has happened, something has gone and happened, and that is also, they say philosophically, that such Kali Yuga has come and they have destroyed, and again it will, you see, the nature itself will destroy us, and again there will be recreation. Death and, you see, birth is a cycle, and we are also getting into that death stage. So this is a part of that, the deterioration. So we have to one day go. So we are in that process. So that also is there. But once we go, the question now is, can we tell ourselves, the man, can he say, yes, I have done something wrong, but I am trying to correct myself. I think that's what the human man is now looking at. I have done something wrong. See, I am the only species in this whole planet which has got a thinking power. So the whole blame has come to me. Now I am the person who has done this. So can I take that blame? Is the question now all of you have to now think about. So curtailing that, if I can say, no, please wait, I have done something wrong, let me do something. Are we late? Or are we too late? Or in this confusion, is man himself getting into problems of fighting himself and killing himself? That's also another problem that now the modern man is now, this times, as you see the world, is now getting into more and more difficult or even unimaginable time where are we going to destroy ourselves? Now these are the two spheres in which we are looking at. Is man destroying himself? Or is he trying to curtail whatever the mistakes has happened? Has he been able to rectify himself or do something best? And trying to sell back, okay, at least we go, when we die, we go with the feeling that yes, we do respect, and okay, if we have done something, okay, let us go through that process of the karma, whatever that we have to do, let us go. But somebody else is there, that's supernatural power, which will take care of this, the destruction and creation, the part and parcel of that natural, the development. So this is the exactly where I think we are standing today. This young generation, now we are looking to the same generation. This is a generation which is going to see this. See, if we are going to go off, I don't think we'll be there to see all this. We are the passers-by, almost we have come to the end of stage, so we are just going out. Now you are the people, the young generation, the people who are now going to face these problems. For this generation, now my advice to you is, my children, let me tell you, think of yourself. Go back, you think of yourself. Try to understand who you are. Until unless you understand who you are, you will not have any answers. The whole picture opens up and says, if I know who I am, can I be in that sphere? And then can I be of help if I know who I am? If I don't know who I am, I'm in the darkness. Then I'll not be able to do anything. So this is the challenge that it is to you, it is in you to you. I don't think there's anything else for us to talk about. I only pray God that He gives you strength to understand yourself. If you can do something good, something which creates, not destroys, just creates. Just give one seed and try to take care of that seed. And that seed, if it grows into a beautiful tree, with so much of fruits, so much of leaves, so much of good air, food and water, everything which gives, if you understand that, I think we would have been part of that group. So God bless you. Let the ideas come out within you so that you can protect the environment and this planet. Thank you.
Thank you so much, sir, for those motivating words. Now I request Professor Gopal Krishnan to propose the vote of thanks.
Good morning to all of you. So on behalf of Indian National Academy of Engineering, INAE Bangalore chapter, I welcome you all. And today being the Engineers Day, greetings to all of you. Respected delegates on the dais, it is my pleasant duty to propose the vote of thanks. As you are aware that INAE does several flagship programs to promote engineering solutions to the mankind. And one of this we thought to be held on the Engineers Day, that is the birthday of Sir M. Vishweshwaraya. We wanted to propose something that is affecting this planet caused by ourselves. And our two previous speakers, Dr. Jara, Dr. Atre, had brought this out. And this is what we've been debating for several years, as Dr. Atre said, for the last 3 years. And eventually we said that this has to be a student-centric program. Student has to be made aware of the evils that we ourselves are creating to destroy this planet. So this whole idea of doing this year after year with the same thing came up, and we chose Ramaya College, our Gokula education friend, as our partner to propagate this idea, bringing awareness into this. So I thank the Ramaya management, the Gokula Education Foundation management for agreeing. We have entered this MOU. We are going to be here year after year so that you became aware of it. It's a student-centric program. So I come to the vote of thanks part of it. I really thank the chairman of the Gokula Education Fund, Federation, Foundation, Dr. M.R. Jairam, for having accepted to be the chief guest and delivering his address. Thank you very much, sir. Of course, this whole idea was conceived by none other than Dr. Atre, former SA to RM, DG, DRDO. So I thank him for guiding us, leading to all of this, his perseverance. As he said that we tried for last 3.5 years and today it has materialized. I really thank him for guiding us, and please give him a big hand because it is because of him. So I also thank our Chief Executive GEF, Ram Prasad, for making this happen. Of course, the star of the show is, I'd like to thank two people, that is our principal, Dr. Naidu, and Dr. Dixit. Without it, they have toiled very hard to bring people together to have this. And we structure this program such a way that first we want to introduce what this problem is. So, and different angles. So we have three very distinguished speakers, Professor J. Srinivasan, Professor Dasapa, and Professor Goswami, who will bring you the focus why we are here, to bring you awareness of this problem. I really thank them for having agreed to do that. And the program is such a way that, as I said earlier, it is student-centric. We will have a number of student participation coming from here. We handpicked colleges, 4 colleges, 2 groups each, to start with. And we want to expand this next year. To see, first we want to see how this goes. We have given you a set of topics on which we want to see as engineers what kind of solutions you are going to give. So I thank all the colleges, their groups, their student leaders for having come here. Thank you very much for coming. And we have assigned some very nice prizes so that you get motivated. So we have 3 jurors here who will be judging your presentation. I thank Professor Pradeep Datta, Professor Ramdeep Ambiraja, and Dr. Chanakya. Chanakya is going to be coming. For all of the 3 who are going to actually assess your presentations and see how well you understood. And I hope, I'm sure that all of you have done a wonderful job to do that. And I finally thank my colleague Pramod. He had toiled very hard to do that. Because of him, he has worked very closely with the Ramaya group consisting of Professor Dikshit, Dr. Siddesh, and Dr. Haridya. So thank you very much. Thank you all for attending. It was wonderful having you here, and hope you will have a wonderful session. Thank you very much.
Thank you, sir. We have come to the end of the inaugural function. So we will break now for tea, which is served outside the hall, and reconvene in 10 minutes for the talk by Professor J. Srinivasan.
ರೆಡ್ ಕೇಬಲ್ ಇಲ್ಲಿ ರೆಡ್ ಕೇಬಲ್ ಕೊಡು ಕೊಡು.
In their own fields. Okay, so I'm going to tell you a few things that you might not find about them on the website, you know. So I've been a student of Professor J. Srinivasan's from 99. So he has nearly about 50 years of experience in teaching. So you can look at the legacy that what he brings in here today. And I'm sure as a student, you would learn quite a bit. So when I took his first course in thermodynamics, then, you know, he used to just send a teaser to us. He said that, well, ask me a question that it'll make me think and I'll find it difficult to answer, then you'll get an S grade. So with that note, I would actually tell you that he loves, you know, being asked questions, tough questions. Okay, so at the end of his talk, I'm only encouraging you to ask him many questions, and I'm sure that he's prepared. He told me that I would like to hear from today's generation what they think about climate change. So I would leave the stage with that. But just to tell you a little bit about him, Professor Srinivasan has worked on various committees. It's fine. Across India and across the world. He was also there at NASA. You know, many of you were revere to be there at such organizations, and he's also been instrumental in many of the government policies that drive climate change policies particularly for India. So with this, you know, let's give a warm welcome to Professor J. Srinivasan, the first speaker of the day today. Thank you.
Good morning. Thank you, Pramod. So the talk I'm going to today is what can engineers do about climate change? But before I come to this topic, I will say something which many of you may not be happy about how engineers contribute to climate change. We are in the state today because engineers, without realizing that they can have an impact on the global environment. Okay? Now, I've been talking about climate change for the past 36 years on various forums across India. And I find that many engineers are climate skeptics. They are all my classmates. They are climate skeptics. They think, how can engineers affect the global climate? The Earth is very big, and we cannot really change the Earth. Okay? Now, how did engineers contribute to climate change? Through development of technologies to extract coal, oil, natural gas, and finding novel ways to use this to generate power, run vehicles, and produce plastics. Okay? And what happened in this is engineers ignored the impact of the technology on Earth's climate. They thought that Earth's climate is stable, human actions cannot disturb it. It's very big and we can do what we want, it will manage. Unfortunately, it does not. Okay? So I think what is missing in the education that I got as an engineer, and most of you got, is that we are not been taught that products that they create, engineers create, has the potential to harm the environment. Okay? That issue was never a part of the syllabus. We are always taught engineers are good guys. Of course, they are good guys. They are trying to do good things. But without their understanding, it's possible that they will affect the global environment. Okay? Now, I must point out, the person who was most aware of this was not an engineer. It was Mahatma Gandhi. Okay? Now, 95 years ago, not today, 95 years ago, he made the following statement after going to England. He said the economic imperialism of a single tiny island kingdom, that is Britain, is today keeping the world in chains. That is, England attained prosperity by looting the whole world. Okay? And when he saw the prosperity, he asked himself, if an entire nation of 300 million, that was India's population at that time, okay, took to similar economic exploitation, it would strip the world bare like locust. Okay? This is a very profound statement from a great person, and I don't think anybody ever thought about it. Okay? This was made in 95 years ago. And because Mahatma Gandhi's intuitive understanding of what is sustainability is built into this concern. Okay? Now, of course, today we are more sophisticated, we can explain that better. So today one will highlight it the following way. When I learned engineering, I was told that I should make a product which is economically viable. otherwise nobody will buy it, right? So that was the main focus for all of education. I'm sure even now most of the focus is on how to make something which is economically viable. But the two other issues were equally important, which is environmentally bearable and socially equitable. Okay? So these three come together to make it sustainable. This is what has not been taught, and I hope in the coming years the curriculum of engineering in India is changed so that right from the beginning the students are aware that they are responsible not only to make something viable economically, environmentally bearable, and socially equitable. Okay? Now, there was a nice book published 50 years ago called The Design for the Real World by Victor Papanak. Very fine book. Unfortunately, I don't think many colleges use it. How many of you have heard about the book? No one. Okay? So this was taught in IIT Kanpur by my colleague, Professor Vijay Gupta. It's a wonderful book, the first book which connected engineering to human ecology and social change. Okay? So what we do is just not technical. It also affects human beings and the social thing. Okay? One example I'll give you here. Chemists and engineers have invented 100,000 new chemical substances which don't exist in nature, okay? New ones. Okay? They never thought that this can accumulate rapidly and affect the atmosphere. Nobody thought about it. Okay? And that's because they didn't think of the environment. They thought of only their great invention they made. Now, one example I'll give you is Thomas Midgley, very well known. He got many awards for invention of chlorofluorocarbon. When I was a student, we were told this is a miraculous substance which is odorless, non-corrosive, non-flammable, does not react with anything, beautiful substance. You release it in this room, nothing will happen to you. But that was the weakness of the substance. Since it was not reacting, when it leaked out of the refrigerator and air conditioners, it slowly moved into the top of the atmosphere, where ultraviolet broke it into chlorine and fluorine, and they are highly reactive, all of you know that, and that destroyed the ozone hole. So ozone hole appeared suddenly in the 1980s, and only then people realized that we must be careful about releasing anything into the environment which has a long life. Okay? If that was short time, no problem. It will react and it will become something else. But if you release something which has a long life, it will build up in the atmosphere and can cause problems. Okay? The other thing which we were told by many people, that as we progress, pollution is the price we must pay. Okay? For air pollution, for example, such a serious problem in India, people don't realize it can be controlled. But they think, no, it's necessary, without that we cannot progress. So this attitude also has to be changed. Again, for this, the engineering education has to change. Okay? One cannot accept that there's no, that whatever we do will have some bad impact, we cannot avoid it. That attitude should go. Now, other issue regarding climate change among engineers which cause some lack of understanding is, there are three things which we should know about. One is weather. Weather, all of you know. Weather is something all of us get up every day, every morning. Is it going to rain, or it's going to hot? What dress to wear? That's very easy, okay? But climate is not same as weather. Climate is somewhat different weather. So climate also fluctuates year to year. No 2 years are the same, okay? And that is natural. That we have to live with. Finally, there is climate change, which is occurring over a long time scale, 30 to 100 year scale you're talking about. And that change is occurring now on account of human beings, okay? So many people did not believe that human beings can alter the global climate. And I'll give a very good example that just appeared recently. We have been extracting groundwater very rapidly, both in Karnataka and the rest of India. And we have removed so much water from the ground that the North Pole has shifted by 4 centimeters. Can you parts per million, it has a huge impact. Now, 3 years ago, when we had the COVID pandemic, people understood it better because a parasite just 100 nanometers long completely affected our life. All of us were confined to our house for 3 months. So you must understand something being small or in small concentration does not guarantee that it doesn't affect your world. Okay? Now the other reason why people have this impression that climate of the earth will not change is because of an unusual reason. We came out of the last ice age 20,000 years ago, and there was a very rapid change, and then we came into the so-called Holocene, the last 12,000 years. In that period, the climate of the earth remained absolutely stable, around 50 degrees centigrade global mean temperature, okay? And so human beings got used to the idea that temperature is very stable. Now, ironically, it is because the temperature is stable that agriculture thrived. 12,000 years ago, there was no agriculture. Whole world population was less than that of Bangalore, okay? Imagine. Entire world population was less than Bangalore. So we had no impact on the environment. The earth was in delicate equilibrium, maintaining its temperature a little bit up and down. Whenever there was a volcanic eruption, temperature went down and then it came back up. This is a natural cycle that the earth went through for 10,000 years, which enabled agriculture to thrive. Okay? The agriculture thrived only because we had a stable temperature. But in the last 100 years, our temperature has gone up by 1 degree. The previous natural fluctuation was 1 degree in 1,000 years. That's a slow change, okay, from the last ice age. So what people don't realize is that Earth's climate has oscillated between completely ice-covered Earth and completely ice-free Earth for millions of years, okay? It's a natural cycle. It depends on the sun's radiation falling on the Earth. All of you know Earth goes around the sun in an elliptic orbit, and the axis of rotation also changes, but they're all slow things. And when these things are slow, the Earth adjusts to it, goes through various cycles. Now, why is there different states of the Earth's climate? That's because the Earth's climate is, for the present incoming radiation of the sun, Earth could have been in a completely ice-covered state, or a completely ice-free state, or in between. Okay? How is that possible? Because the absorption of solar radiation from the sun depends on amount of ice, snow, and cloud on the Earth. Okay? And the amount of snow, ice, and cloud depends on temperature. Okay? So there's a nonlinear interaction between radiation absorbed from the sun and temperature. The temperature is very high, all the ice and snow melts, and you'll have very high temperature. If the temperature is very low, entire Earth is covered with ice. It's called snowball Earth. It happened about 600 million years ago. Okay? So you must remember that Earth's temperature is not stable, and we human beings, if you're a little careless and push the Earth away from the present stable state, you don't know what will happen. Okay? That is the warning that is coming up very clearly. Okay? Now, what have we done? By reckless exploitation of fossil fuels for the last 150 years, we have increased the carbon dioxide concentration from 280, now it has crossed 420 this year, okay? Now, when I talk about this, many people ask, how do we know this is causing climate change? Now, you must remember that although CO2 concentration is very small, the unusual property of the Earth is, all of you know from your high school that Earth contains nitrogen, oxygen, and argon. That constitutes 99.9% of the atmosphere. Those three gases don't absorb any radiation, either sun's or Earth's. They are totally transparent. And because of that, the minor gases like carbon dioxide, water vapor, methane, chlorofluorocarbon, they are playing a role. Because the major gases are doing nothing. Okay? That's an unusual feature. Now, how do you know it's true? A lot of people debated this for 100 years. Today, we have very complex climate models. We have powerful computers. So we can run a model in two different ways. One, keep the carbon dioxide at 280 parts per million, as it was in 1850, and run the model with many initial conditions. It will fluctuate around 0.2 degree, like it did for 10,000 years. Okay? In the same model, you increase CO2 to value around 400 parts per million. It will start increasing around 1960 very rapidly. Here, the black is observation and red is a model. Model is not perfect. There are errors in the model. But by and large, the model correctly predicts that the increase in temperature in the last 60 years is solely on account of increase in carbon dioxide. Okay? Now, I was warning you that this is the global mean temperature, whose prediction is quite accurate. We can compare with satellite data now. Okay? But remember, the models are not very good predicting rainfall. Now, if you were to ask me, due to global warming, what will be Bangalore's climate in 2050, I cannot answer it easily, because that will depend on how Bangalore develops, how much of urbanization occurs, how much of greenery is there, how much of how many lakes are there. Only that will determine the temperature, not CO2 alone. So must remember that predicting the future on a smaller scale depends upon what happens on that scale. But global mean temperature is controlled primarily by CO2. Okay? Yeah, this I've already covered. Now, let me tell you, CO2 is the trigger. CO2 is not the only gas causing global warming. What happens is CO2 increases due to human action. Okay? Without human beings, CO2 was kept stable by natural adjustments. Okay? When CO2 increases temperature by, let's say, 0.1 degree, immediately whatever goes up by a law of thermodynamics called the Clashes-Clapeyron equation, which dictates that as soon as the temperature goes up, water vapor has to go up. Water vapor is a more powerful greenhouse gas than CO2. It absorbs much more than CO2. And so it has a higher greenhouse effect. Temperature goes up and it changes clouds, it melts ice. All these are reactions to this trigger. So in the case of Earth, CO2 is the main cause, and the consequences are due to various reactions are going on, which release more of these gases, melt the ice, you absorb more radiation. So this is the reason why temperature has gone up by 1 degree in the last 60 years. Now, the other important issue which engineers find difficult to believe, that how can 1 degree warming can be so serious? Because remember that between day and night, there is 10 degree difference. Between winter and summer in Delhi, it is 20 degrees, 30 degrees. So why 1 degree? 1 degree, remember, is global mean. And global mean 1 degree is only a measure of how much heating has occurred. All that 1 degree is the additional heat stored in the ocean. Okay? Most of the additional energy trapped by CO2 is in the ocean. Okay? Slowly it will come out. It's coming out as more massive cyclones, more massive flooding. All those are consequences of a warmer ocean. Okay? Now, those people who don't believe 1 degree is serious should look at what happened a few years ago. Okay? 200,000 saiga antelope died of infection in just 3 weeks in May 2015. And when the doctors investigated it, they found that the virus was already there in the antelope. Because of 1 degree warming, it became more virulent. Okay? The antelope and the virus were in equilibrium for a million years. And suddenly 1 degree warming caused the virus to become more virulent. So this is the consequence of 1 degree warming. Okay? It may seem small, but in biological systems, 1 degree is pretty large. Okay? And the other thing to remember is this important distribution. When we say 1 degree, the present climate is the dotted line here. After 1 degree warming, it shifts, the distribution shifts by 1 degree. But look at what it causes in terms of hot days. Now we are experiencing hot days both in Bangalore and other parts of the world, which were never experienced before because the whole system was shifted. And the cold is, as a matter of fact, I've been in Bangalore for now more than 60 years. I can tell you I have not seen any temperature like 12 degrees, 13 degrees in the last 10 years. I don't see it because you're gone out of this area. And we are seeing more around 35, 36. When I came to Bangalore, not a single house had a fan, no fans in Bangalore. Okay? Now, many of you cannot manage without air conditioner. Okay? That is the impact of 1 degree warming. Bangalore has warmed by 2 degrees, not 1. That's because of local effects. Okay? Now, Professor Hansen, who was the director of the NASA labs, he pointed out, because of 1 degree warming, the area which is subject to very high summer temperatures increased 50 times. Some of us wanted to appreciate the nonlinearity of the problem. 1 degree change causes the number of regions with high temperature to go 50 times in the last 50 years. Okay? Now, if you look at the condition in July this year, many parts of the world were 8 degree warmer. So 1 degree is only global mean. Locally, there are parts, especially in the polar region where ice is melted, 8 degree, 10 degree warmer. There are huge heat waves, forest fires. All these are due to 1 degree change in global mean temperature. Okay? Now, if you look at the data, the number of heat wave days is increased, they are occurring more often, they are becoming longer, and the first heat wave occurring earlier, and the hottest day of heat wave is becoming hotter. So all these are consequences of just 1 degree warming. Okay. Now, this 1 degree warming did something a few years ago which I could not believe. There was a place called Yukon in Canada. Okay. Hardly anybody lives here, that's why you don't hear about it. A river changed course. How can that happen? So because of 1 degree warming, and warming is more in Canada than in India, the glacier started retreating. Okay? So let me show a photograph here. Here is the glacier. Okay? It feeds 2 rivers. Okay? And as it retreated, it cut off the supply of water to one of the rivers. Okay? That river dried pretty much overnight. Okay? Now, you won't hear much about it because there are no one is living there. Nothing happened, but it was something which nobody could believe when they saw it. And just imagine in India, one river coming out of the Himalayas suddenly shutting off. 1 million people will die because we are dependent on a river very much. And if the glacier retreats and does not supply water to one of the branches of the river, the consequence will be very serious. Okay? Now, other example, of course, is extremely high temperature that was experienced in Canada a few years ago. That's because there is a jet stream which is flowing across from west to east across the mid-latitudes, and it fluctuates sometimes, and the fluctuation increases due to global warming. Okay? And because of that, hot air from the tropics enters British Columbia in Canada. Okay? Now, British Columbia is a fairly cold place. People who build houses there don't have fans, don't have air conditioners. You don't need them. It's a nice, cool place. So all of a sudden, this area, I couldn't believe the number, reached 49.6 degrees centigrade. Okay? This is 15 degrees above what you see in Bangalore, 14 degrees above. Okay? So you can imagine people living in that cold climate suddenly get 49.6. Large number of people died. They're not poor people, they are prosperous people, but they were not ready for it. But irony is, this happened in 2021, but 20 years before, the Intergovernmental Panel on Climate Change gave exactly this warning. If you read the account very interestingly, it says parts of Canada and North America will experience very large heat waves in regions where people are not used to those temperatures. And a lot of people didn't believe it when it was mentioned 20 years ago, and it happened exactly as mentioned. The other important thing recently, Chinese have found out that in glaciers which are melting in Tibet, never before seen viruses are coming out. They are trapped and frozen in the glacier for 20,000 years from the last ice age. Okay? Now they are coming out. We don't know what are the consequences of that. Many of them may not affect us, but we don't know. So you have to remember that just a 1 degree change in temperature has so many consequences, which most engineers did not even realize. Okay? Now let's come to the issues here. The first issue we faced when we had global warming, when people started realizing it, was to understand how that change occurred. Okay? The scientific challenge. So I would say that is more or less understood. Today we have models, we have good understanding of why that 1 degree change occurred and who are the major contributors. So now the issue is technological. Now that we know CO2 increase has caused this, how do we stop the further increase of CO2, and how do you bring CO2 back to around 280 parts per billion so that the Earth can live in equilibrium with all its natural factors. Okay? The next three are the most difficult part, some of you have to face it, is the political challenge. When you go and talk to politicians about climate change, they don't want to hear it because it's a long-term problem. It's not a problem tomorrow. It's a problem for the next 30, 40, 50 years. So most politicians in a democratic country don't want to listen. They want to know what will happen before the next election, right? So this is a very difficult problem to convince politicians that they have to deal with the problem now to prevent catastrophe later. Okay? Now, the last one is to all of us, social challenge. You have to convince people to change their lifestyle. We have to heed to the words of Mahatma Gandhi that there's enough in this earth for all of us, but not if you're greedy. It can satisfy all our need, but not our greed. Okay? That has to be highlighted now because we live in a consumer and market-oriented society where we associate our happiness with material things. And that's what's causing all this problem. Okay? It's just not the mistake of engineers or something. Every one of us is a part of the problem. Okay? That is what you have to, okay. Now, when we now talk about the need to control this global warming, many engineers told me it will be too expensive to mitigate climate change. They're absolutely wrong. It will be too expensive not to mitigate climate change. If you don't do it, you are gone, because you thought COVID was bad. Climate change is much worse. Climate change essentially threatens your existence. COVID was for a short time. We found a vaccine. We overcame it. There is no vaccine for climate change. The only vaccine is, like we are using our masks during the COVID, we have to control our greed, okay? Now, ultimately, after many years of debate and discussion, the Paris Agreement came about, which was a major milestone, but I must tell you that it is not a great agreement because it is voluntary, it's not binding. The previous agreement, which was done about 30 years ago, which is the Montreal Protocol for controlling ozone, that was binding. Okay? If any country did not obey it, they can be penalized. But this one is not yet binding because it's not easy to convince all politicians on this issue. But as the things get worse year by year, it will happen. It's a matter of time. Okay? Now, what is the challenge? The challenge is we need to rapidly reduce the CO2 emission we are doing now from around 40 gigatons of CO2 to almost zero in the next 20 to 30 years. Okay? And it's not easy because in the society, any transition, whether from wood to coal or coal to oil or oil to gas, it takes about 50, 60 years. Now, because we woke up late, because we didn't realize how bad it was, we have to do it rapidly. Okay? So this is where the challenge comes. Now you might ask, why should we worry about doing it rapidly? What if we do it a little slowly? Warning is always coming. This is a photograph of what is happening in Russia. In Russia, there is frozen soil called permafrost, frozen for the last 20,000 years, which contains methane. Okay? Methane is trapped in that soil. Now, as the temperature in Russia is increased by 4 degrees centigrade, not 1, but 4 degrees, the methane is coming out. You can go and light a matchstick, you'll see flames there. That's a methane flame. So as the earth warms further and further, more of these flames will appear. And in some places, it's not flame, the methane will come out in large amounts, okay? And methane is a more powerful greenhouse gas than carbon dioxide. So this is a warning that if we don't do anything, things can get worse very rapidly. To understand that, I'll use a mechanical analogy. We came out of the last ice age due to some changes in the Earth's orbit, and we came to the present climate. Now, the way we are perturbing the present climate, if we perturb it beyond our 1.2 degrees, you might reach a state which is much, much hotter than today, and which will be not easy for human beings to survive. Okay? As a matter of fact, you must remember that the only species which will enjoy the warm climate are the insects, because insects do not have temperature control. We have. I cannot survive the temperature go much above 35 because I have to maintain my body temperature 37 to keep my CPU cool, okay? If we can't do that, we cannot survive. But insects have no such, insects can survive in any condition. Temperature gets hotter, they will adjust to it. So it's very clear all over Canada and Russia, beetles have increased like anything because they like the warmer climate. And so they are going to cause the maximum problem in the future, okay? Now, the other point I think our engineering education has not taught us is that engineers can make error. We are not perfect. Okay? There's a very nice book, and how many of you have seen it, should be a part of the curriculum. There's a book by Petrovsky, a civil engineer, To Engineer is Human. There are case histories of error and judgment in engineering. Lots of examples of bridge failures, building failures, other things. So this should be taught to all engineers, that you can make a mistake which can have a serious consequence. So to me, that is what is lacking in today's education. I hope over a period of time, our education system will change. As a matter of fact, this is the right time. As all of you know, when I went through engineering education, it was a long time ago when there was hardly any information available easily for us. Okay? So our teachers worked very hard, went to the library, gathered information, gave it to us. Today, that's not necessary. Today, information is on your fingertip, on your mobile phone. So there is no need to repeat information. As a matter of fact, I think the curriculum of engineering has been completely changed. So the information-oriented things should be kept away. Maybe you can examine for it, but not taught. What you should taught is about innovation, environment, and how to make the earth more livable. So that requires a lot of project-oriented learning, not lecture-oriented learning, okay? Now, having seen what has happened in the past, you must realize that all the engineers contributed to this global warming. They are equally important for the transition from the fossil fuel era to the renewable energy era. It has already started, but in order to make sure that transition takes place rapidly, you will need a lot of effort from engineers, policymakers, and also politicians. Okay. Now, why is that? Because almost all the activities we are involved in today involves carbon dioxide emission. Whether it is electricity, heat, agriculture, buildings, transportation, of course, production of steel, everything involves CO2 emission. Every one of them has to be changed. And it's not going to be an easy task, okay? So this is a difficult challenge, but I would like to tell you that every crisis is an opportunity. So many of you may be feeling very depressed reading newspapers about all kinds of disasters and future being very bleak. Yeah, there are problems, but whenever there's a crisis, there's also an opportunity. So all of you have a chance, I wish I had it, to do something new, different from what was done for 100 years. You have to throw all the IC engines out, bring in complete new technology. It's already happening, but you can contribute more to it, okay? Now, I can tell you 20 years ago when I was pleading for solar at various forums, I was told the following: solar power is not reliable, solar power is not sufficient, land requirement is large, availability is poor, and it's expensive, okay? Now, 20 years ago, the last statement was correct. Solar was expensive 20 years ago, okay? But it has changed, okay? All the others are not true, okay? Of course, solar power is not available all the time. At night, you won't get it. So you need storage. That is a big revolution coming on storage, which all of you will see in the next 20 years, okay? Now, let me give you a few examples of how things have changed. A lot of people told me solar is unfit for India because we don't have enough land, because we are a highly populous country, land is not there. That's not that relevant today. You can put solar panels on the lakes, on the sea, okay? Now, other thing interesting is, people who say solar is not possible because land is not available must know that a hydroelectric dam submerges more land than any solar power plant. We are not worried about that, then we shouldn't be worried about solar, okay? And the main advantage of what happened in the last 10 years is the rapid decline in the cost of solar cells. And it's amazing, it came to a factor of 1,000, okay? Now, this is the power of mass production. And what is amazing is, remember, this reduction came not because of big research development or breakthrough. It was just making something in large numbers, okay? This is the revolution which Ford started in early 20th century, and it's applicable to everything, including your mobile phone. Mobile phone, all of you know, the amount of R&D gone is in hundreds of crores. We are not paying for it because billion people are owning mobile phone. But I can tell you, the great achievement of a mobile phone is also its problem. In India, there are 1 billion mobile phones, and we are changing mobile phone every 4 years. Where is it going? I don't know. I kept it. I don't know where to put it. So unless we come up with a way to recycle this mobile phone, which contains a lot of plastic, about which we're going to talk about in the afternoon, a lot of toxic material, silver, gold, everything is here, but there is nobody coming there to pick it up and recycle it. So this has to change, and people have already realized it. It's going to happen. Okay. Anyway, I'm very happy that India is now having a revolution in solar, and I couldn't believe it. In the last 15 years, from almost nothing, we have an installed capacity of 63,000 megawatts. I want you to compare this with nuclear, which is around 8,000 megawatts. The reason I'm telling you is that, none of you may know it, in the 1950s, there was a very interesting debate between two well-known scientists, Homi Bhabha and Meghnad Saha. Okay? Meghnad Saha made major contributions, and Homi Bhabha was a well-known nuclear scientist. So Meghnad Saha became member of parliament. He won an election, which is very unusual for a scientist. He won an election to Lok Sabha. He went there and told Nehru, India's future is in solar. So Nehru said, fine, have a debate. They had a debate. And so Meghnad Saha made a strong case that the only resource India has is sun. Our coal is poor quality. Our uranium is hardly there. So India should go only on sun. But unfortunately, after the debate, Meghnad Saha's view was not taken up. But now we have woken up. But if you had done at that time, similar to the Indian Space Research Organization, if you had an Indian Solar Organization in 1950s, we would have been the world leaders today. Today the world leader is China. We are importing everything from there. I hope that changes. But I'm very happy that in a matter of just 20 years, from nothing, we have come this far. So this shows we can do things. We just have to realize that it can be done. Now, if you want to understand more about how renewable energy can solve all our problems, there's a beautiful article in Scientific American published again more than 13 years ago, showing that we can meet all our needs from solar, wind, and hydro. We don't need coal, we don't need nuclear, we don't need anything else, okay? Can be done, okay? And there's been a lot of debate about it. A lot of Americans didn't believe it, and they actually tried to accuse that author of something, and there is a court case going on in US on this issue, okay? Now, this has driven a lot of creative energy now, which I'm very happy about. I'll tell you, just recently, there was an electric aircraft. This is only flying shorter than 100 kilometers. Still, it's a major achievement because all of you know battery is very heavy. So designing an aircraft to fly is a challenge, but it has been done for a short distance. Okay? And yesterday I heard that Germany has produced a hydrogen-powered aircraft. And that's also a huge achievement because hydrogen has this problem with being very dangerous, but they are using cryogenic hydrogen, not gas. Okay? So a lot of things are going on, very creative things are going on. I hope the young people here will get into this exciting phase of transition we are going through, in which a lot of new things have to emerge in order to have a more safer world. The other interesting thing happening is the world's largest solar powered boat. Okay? And so a lot of people are getting into it. There are people designing zero emission ships. If you remember, 300 years ago, the largest sailing ships were in China. They built huge ships. Okay? Then all that collapsed after fossil fuels came. Now it's going back to that. We'll have huge sailing ships and ships with solar panels and so on. Now, the people are worried about not enough land, about conflict between agriculture and solar, should not worry about it because you can work them together. Okay? Now, why? Because not all plants require a lot of radiation. As a matter of fact, some plants love shade, all of you know that. So you can cleverly combine solar panels and agriculture in a very clever way. And so this has already started, and I hope in India they will get into that mood so that farmers can benefit both agriculture as well as photovoltaic panels. Okay? Now the most interesting thing where India is doing something new is, I don't know how many of you know, a program called Shunya. Okay? Very interesting name, which was initiated by Niti Aayog. So they initiated this to make sure that there were more than 70 million zero pollutant deliveries last year. What I mean by that? All of you are getting from Amazon and other places things delivered to your house by usually polluting three-wheeler. Now all that is going to become electric. Okay? That's a very nice move from Niti Aayog, and I hope that accelerates so that the pollution level, which is one of the major threats to our life, is going to go down in the. We already see electric scooters in Bangalore, very happy about it, although I cannot hear it. But the revolution will start now in electric vehicles, both two-wheelers and three-wheelers, and India is leading that. Okay? But having said all that, remember, no technology is without a problem. Okay? Solar also has a problem. Not land, not other things, but disposal. See, we are building a large amount of solar power plants all over the world. They last about 20, 30 years. After that, what are we going to do with it? Same problem as this. Okay? A solar panel contains millions of these like this. So unless you start planning now, 30 years from now, we'll have a serious problem of disposal of photovoltaic cells, okay? So people have already thought, so I'm very happy that the new generation engineers are thinking about the future when they design something new, okay? This is a good direction, that you're not happy you've done something new, you're also asking what are the consequences, okay? Now people have calculated how much of waste will be generated by 2050. China will be the leader, of course, 20 million, because they have the largest number of power plants. Next is US, India is third, India is fourth right now, it has become third. And all of us have to find ways to recycle everything, okay? So the new approach should be not just you make something and throw it away, you have to be responsible for it being recycled, okay? So reason why I'm saying this is, we are not taught in our college, at the design stage, you should talk about recycling. Design stage, not later. When you're designing something, ask yourself, how will this be disposed of? So people are now talking about the whole cycle by which you can recycle most of the solar panels and reuse it. And that saves cost of mining. Initially, everything comes from mining, or whether it is silicon solar cells or lithium, everything comes from mining. And that cost of mining involves huge environmental damage, and that can be reduced by recycling everything, okay? Now, this was discussed in Germany 20 years ago, okay? But it has not been made popular in other countries. So eliminate the concept of waste. You think of the full life cycle of the product, not just production, and rely on what it called natural energy flows, like wind and solar, okay? So this has to be now made into a law. As a matter of fact, Germany has a law that any person who manufactures, let's say, a mobile phone, has to be responsible for disposal. So I buy this mobile phone from Nokia, which is a Nokia phone really, and I throw it on the road after I use it. Nokia has to pick it up, not me, okay? Because Nokia made money by selling this phone. So Nokia has to be held responsible. So this has to become a law. It's already a law in Germany. In India, they are, I hope they'll pass the law soon, okay? So the point I want to make is, there's a big difference between how we dealt with the virus quite well through a vaccination, but dealing with global warming is more difficult because it's much slower and much more difficult problem, okay? Now let me just remind you what Germany did. They called what is called extended producer responsibility, okay? So a producer is responsible for the disposal. So that means, making this product, he will think, how do I dismantle it? How do I separate out the toxic part, non-toxic part, and everything has to be thought about at the design stage, okay? Now, as I come to the end of this talk, because I want to entertain some questions, what I want to tell you is, when it comes to climate change, you are going to find yourself standing between an escalating threat and an opportunity. So the threat and opportunity both come together, so embrace it and learn to deal with threat and look at the opportunity, okay? So why I'm saying this, I've given many talks to young people. Most of them get depressed when they hear about all the bad news. But the point is that you should see this as an opportunity. You're going to be a generation which will see a rapid transition to a totally new energy system. And that means you can contribute to this new technology and make sure that you are a part of a technology which reduces pollution and does not deploy the environment. Now, recently, when all this was discussed, the IPCC, which is the most important organization on climate change, they have said something very interesting. Because you can get easily frustrated and depressed. Is that every action matters. Whatever you do, think about the environment. Every bit of warming affects us. Every 0.5 degree warming is going to cause more problem. Every year matters. Don't say I'll do it tomorrow or day after. Every year matters. And every choice matters. What choice you make, whether you buy an IC engine car or electric car, it matters, okay? So this is the warning given. But I'll end with the comment by Leonardo DiCaprio and Greta Thunberg, that history will judge both my generation and your generation by what we do today to help guarantee that future generations can enjoy the same livable planet that we clearly enjoy. Thank you. Yeah, type of questions, and
Yes.
I hope, I'll give you a comment I always make in my class. There is no stupid question, there are only stupid answers, okay? You can ask any question, they're not stupid. Every question has something written in it, and you don't feel that you are revealing your ignorance. You are not, you are revealing ignorance of everybody else, okay? So go ahead and ask questions. We'll start with Professor Atre.
Okay. Srinivasan, you have heard of this geoengineering.
Yeah.
Is that a possible solution for?
Yes, you are right. A lot of talk going on in geoengineering. Now, let me tell you, initially, geoengineering was proposed by all the fossil fuel companies so they can continue to produce fossil fuels. Okay, that was the first reason. The reason why geoengineering is such a dangerous proposition is we don't understand the full Earth system. Okay, we are not able to forecast climate or weather beyond a week. Climate is much more difficult. So if geoengineering is done, the consequences are not clear, okay? Now let me give you one example. One geoengineering is very popular, may work quite well, is putting reflecting aerosols on the stratosphere, okay? Now that will weaken the monsoon. Are you ready for it? Okay. Now, interestingly, of course we already done geoengineering. In the last 60 years, as we burned coal, we not only released sulfur dioxide. So there's already aerosol in the atmosphere due to our actions. Now the complicated part is, as India and China decide to have clean air, we will reduce the SO2, warming will increase further. That's another problem, okay? Now the only problem with geoengineering is, it is very difficult to come to an international agreement as to what amount of geoengineering is good for whom. Okay, whether it benefit America, benefit China, benefit India. As a matter of fact, I will not live to see that, but I won't be surprised it is a world war on that count. Imagine China becomes extremely warm. It decides on its own to put sulfate aerosols in the stratosphere. What will we do?
Is it a localized phenomenon?
No, it won't local. See, when you put it in stratosphere, it will spread everywhere. See, volcano, when it erupts in Indonesia, next year the aerosol is everywhere in the world. Local is very difficult because when you put it in the lower atmosphere, it will come down immediately. You have to put it in the upper atmosphere, and there are a lot of winds that will carry around the globe. So local, I don't see a simple solution. But let me tell you in this example. Last 2-3 years have been very unusual in Earth's climate. Suddenly parts of North Atlantic and North Pacific became very warm, much warmer than what they're saying. Now, one of the reasons, it turns out, it is not proven, but it looks like that. About 2 years ago, the International Maritime Association passed a law to prevent ships from burning dirty fuel. Dirty fuel means a lot of sulfur in it, okay? Now, when they did that, the sulfur fuels being sulfur dioxide, which brightened the cloud, it caused more droplets to form. So in the last 2 years, those clouds have become less bright. Suddenly that area has become very warm. So already we are doing it locally. It's already happening, okay? Now, if you want to do it globally, you have to go upper level. And there are problems. But I can tell you, in spite of all this, research has to be done because, as it happened in the case of ozone, we suddenly had ozone hole without any warning. If something horrible happens to global conditions, then we may be forced to do it. Okay? So research is going on, not because we believe we have to use it, but we want to have an emergency response system. Okay? But I don't know how it will be handled. The United Nations is very weak, it cannot handle it. I would like to know how the world can come to an agreement to do something in which opinions differ from different groups. And, but research will be done. A lot of young people will do research in that, but action depends upon our full understanding of the Earth system, which we don't have right now. But knowledge is expanding, we never know, maybe another 20 years, full understanding will be there of the role of aerosols, because right now I can tell you, climate models are being used, but climate models are very poor in forecasting future climate because of aerosols and clouds. Those two are not understood, okay? But it will improve over the period of time. But till that time, I would not risk geoengineering because it is meddling. We already meddled with the Earth's climate. It's further meddling we are doing. Okay? But who knows? We may have no choice. Yeah, I want young people to respond. I'm surprised nobody is willing to ask a question. Yeah.
Nuclear energy, a lot of countries are investing on nuclear energy and looking at it for the future electric power generation. What was your...
See, nuclear is the main problem. India does not have uranium. Otherwise, we had big agreement with the US for that import of uranium. But my main concern, which I'm sure are very unpopular in India of saying that, I'm concerned about what happens similar to Bhopal gas tragedy. Nuclear reactors have to be maintained very carefully. A terrorist attack or a carelessness on the part of somebody will spread radiation, and a country such a high population density cannot afford it. It's all right for Russia, it's all right for Canada, but for India and China and Japan Japan is a good example. When Japan, they built the Fukushima reactor on the coast, all the geologists warned, don't do it, because Japan is subject to tsunamis, well known. Tsunami name comes from Japanese language. But the engineers in Japan said, no, we know how to design. We can design a reactor which cannot, that's not true. So sometimes engineers are overconfident, okay? And so Fukushima is a very good example of a very well-built reactor, but not built to handle a tsunami, okay? Now, many reactors in India are along the coastline because we need water for nuclear reactor. Nuclear reactor is a huge problem, it needs a lot of water. So most are located on river or on the coast, and tsunami is a threat, okay, on both coasts. We saw a tsunami in the east coast more than 10 years ago, but tsunami can also come on the west coast. So the problem of sighting, in India, problem of sighting is very serious. We don't have large areas free of human beings. So that's why, in spite of all the support has been given, nuclear power has gone to 0 to 8,000 megawatts the last 75 years. And until you find a source of uranium, of course, we were told when you are young that there's a whole new thing with thorium, but that has not happened. Okay? But even if that happens, I'm very, knowing that as an engineer, having gone to all the factories in India, I know what kind of safety norms we keep. Nuclear industry is much more safe than other industries in India. Still, India's safety culture is very poor. Find out today how many people wear helmets on the road, in spite of it being a law, in spite of it very clear damage to your brain, you're not wearing a helmet. So India is a country which has got a long way before it has safety norms sufficient to keep nuclear reactors safe. That's my view, okay? Yeah. I can't hear, you have to use the mic.
Yeah. Apart from renewable energies like solar, biofuels, etc., what other mode of technologies are adopted in India to mitigate climate change, sir?
See, there are many more available, but none can match solar. See, there is a ocean thermal energy conversion. We have a warm ocean, and there's a cold ocean below, okay? So that difference in temperature has been used to drive, to get power. But those are small amounts. See, you cannot, the amount of solar energy falling in India, Indian land is so high, that will take care of all our needs. We need maybe 1% of the land area. Okay? So why go for, but I can tell you, in the next 50 years, we will be having offshore wind power plants, maybe offshore solar plants, maybe coming. Because when you start putting a lot of solar plant, large area, there may be some protest from some people. Okay? So wind and solar will take care of most requirements, but look at Lakshadweep. Lakshadweep may have an OTEC, I think there's already one there, built by NIOT in Chennai. So for some island nations, OTEC may be a convenient, because they don't have much land, okay? So they can use temperature gradient in the ocean to generate power, so that's possible, okay? But I'll tell you what the threat there is. You put an OTEC plant of the coast of Chennai, a cyclone hits it, you're gone. So those are the problems with OTEC. As a matter of fact, many of you wonder, what about solar plant? What happened with the cyclone? It happened recently in Florida. A major cyclone hit Florida, 2 or 3 cyclones. Somebody designed a solar plant which was not affected. It's an amazing design. Please look at it. It shows, because one can easily lift a solar panel if we don't fix it properly. They've done a wonderful job. Whole of Florida was destroyed, but that plant remained. That shows the clever design of that engineer, okay?
What about?
You have to talk, keep the mic close to your mouth. I had to hear it.
What about post-combustion CO2 capture techniques and sequestration? So what are your views on post-combustion CO2 capture and sequestration techniques? Post-combustion CO2 capture from flue gases and...
So what are your views on post-combustion CO2 sequestration and capture? Am I right? Okay.
Okay, let me tell you that ultimately we have to bring back carbon dioxide to 80 parts per million. Not now, in the next 50, 100 years. And Unfortunately, once you release CO2 in the atmosphere, it's a very dilute gas. And all of you know, when a gas is very dilute, it's very difficult to put it back, okay? You need a lot of energy to remove CO2. That energy has to come from sun, can't come from fossil fuels. So it's a tough task, but I can tell you, engineers are very smart. In your lifetime, somebody have a solution which is economically viable, okay? There's one plant running in Switzerland, by the way, which is removing CO2, but very expensive. Right now, it is not cost effective. But as I pointed out, in your lifetime, many things may happen which may become inevitable that you have to do that. But right now, it is a pilot scale in Switzerland and a few other countries. They are putting plants in which they absorb CO2, convert calcium carbonate, and put it in deep ocean. So that is going on, but economics is very poor right now. But remember that as it gets sold out, it was so expensive 20 years ago, now it's very inexpensive, same thing can happen. But today is not a solution. It will be a solution 30, 40 years from now, okay? And many of you will see it. It's a very good question because that one has to do a lot of fundamental work to find an inexpensive way to remove CO2 and store it deep in the mine or deep in the ocean.
So as you had mentioned with when we use solar energy, the dead photovoltaic cells is a major problem that we would have to overcome. So do you think by using hydrogen energy or some looking into that avenue, we'll be able to overcome this?
But how do you produce hydrogen? You produce on solar. There's no. See, hydrogen is only a carrier. Hydrogen is not a source of energy, right? Hydrogen is a carrier. So who will produce hydrogen? You will produce it by solar cells only. There's no other way. Okay? Hydrogen is a carrier only. Hydrogen is very convenient as a carrier. For example, for trucks going long distance, or there's a train in Germany running on hydrogen. So hydrogen is very useful as a carrier, as a fuel. But you have to generate it separately. So as a matter of fact, there's a grand plan between Europe and Saudi Arabia and Middle East countries to use the desert to generate hydrogen, liquefy it, transport it to Europe. They are working on it, okay? Again, in your lifetime, you will see it. The Middle East from being oil superpower will become a solar superpower, okay? And Saudi Arabia is very smart. They are realizing that as the oil demand goes down, their economy has to survive, so they are switching to solar. So all that will produce hydrogen. Hydrogen will be produced by solar. There is no other way. Yeah.
Thank you, sir, for the wonderful session. I have a doubt. Like all this while, we have been, or we are thinking of making everything as electrical or more renewable kind of things. So all this while, all this decade, India has produced so many electric goods, electric devices. I am curious to know what is the fate of these electric waste other than landfills, and what are we approaching in the back end to decide on?
Very good question. See, all the electrical products produced are made of plastic. Plastic is a more serious problem than in the immediate future than climate change, and all of you are talking about in the afternoon. Very soon you'll find plastic is recyclable. There's no choice. Okay, you have to recycle plastic or find bacteria or virus which will attack the plastic and dissolve it. Okay. As a matter of fact, only today I read there are colleges going near all the waste, where the waste is thrown, bacteria are growing there. They're going testing which bacteria is growing, which bacteria is killing the plastic. People will find new solutions to that, I'm sure about that. So again, first we need a law. So the point is right now, all of us are aware of plastic pollution. We are not going to do anything because you have to make a law first to slowly reduce use of plastic from all our everyday use and use only recycled plastic. I'll tell you one example which I was really impressed. This is the biggest threat, water bottle, okay? Contains plastic, we throw it away. Thousands every day, okay? Now I saw last year a 12-year-old girl got an award, science award in an exhibition in US for designing an edible water bottle. I was amazed by the girl's achievement because she didn't go to any engineering college, she didn't have any knowledge of biology. So when she won the prize, she took the water bottle and ate it. Huh? you go to the website and look at it. It's a wonderful example, okay? And so she was asked, how did you design this? She said, from Google search. So today, remember that you don't need any degree, you don't need anyone to teach you. Go to Google, can learn anything, okay? That's the beauty of it. I was young today. Whatever you want to know is there, okay? Good and bad, but you have to figure out. So a 12-year-old girl designing an edible water bottle is wonderful, but I can tell you, think about it. It's a very clever idea, but it may not reach the market. Why? If this is edible, how will you transport it? when you're carrying it in trucks, some insect will attack it. So there's a challenge, but I'm sure some company is looking into it. If you make it edible and make sure it can transport it safely, it is a wonderful example. So what I'm trying to tell you is that new solutions will have to emerge for electrical goods, for water bottles, everything, because everything you're doing is not recyclable and poses a huge problem. So I hope all of you will be part of this change and you will keep thinking about new ways of doing this. That's why I'm very happy we have a good startup ecosystem in India. I hope most of you don't look for a job, you look for a way to do something new on your own, okay? I hope you'll do that. Thank you.
Right. So that was I think that was a very enthralling session. So I'm sure that you have a lot of questions. You can certainly catch up with Professor Srinivasan maybe during the lunch hour. Okay, so maybe we'll request Professor Pradeep Datta to hand over a memento to Professor J. Srinivasan. All right. Sure.
A very small announcement before the start of Professor Dasappa's talk. I'm sure all of you looking forward to it. We have some sweets to be distributed on the Engineers Day. I request all the students to be seated in your place and we'll distribute it to you. And please don't litter after that, please.
So students who ask extra questions will get extra sweets. Okay. All right. So while Professor Dasappa, we welcome Professor Dasappa to take the dais. He's the next speaker. So sweets are for people who are going to maintain silence. So, can I have your attention, please?
This one? Yeah. Copy model, sir. Just or shall I play?
Thank you.
You can just do the play also. Just check whether it is possible. Delay agundre.
No, delay nagala. It will copy, sir. Immediately.
I think we should do it while the session's on.
Done.
Everyone will get a sweet. Don't worry about it. Okay. Okay. So our next, can I have a little bit of silence, please? The ladies out here, can I have a little bit of silence, please? Along with the sweets, can I have a little bit of silence? Okay, all right, thanks. And so let's welcome Professor Dasappa, who's going to be the next speaker for us on the dais. So if you can leave the sweets aside and give him a warm round of applause for Professor Dasappa, it'll be good. Thank you. All right, so just a very brief introduction. I know we are running short, we are running behind time. So let's give him a round of applause and he can get started on this. Thank you, Professor Dasappa.
Thank you, Professor Pramod, and thanks INAE and the RIT to have provided this opportunity to share with the young minds what we have been doing, a small contribution towards an epsilon contribution to the decarbonization. I think Professor J. Srinivasan has given you all the recipe to see what needs to be done, why we have to do. And I will just take you to a journey, what has been done, how challenging it is. And he brought in about 4 pillars for success. And I'll just bring out certain features related to some of these things, how they get linked when you really want to look at the science and technological aspect of it. Just to give a brief, IISc is a tripartite agreement between Jamshedji Tata, Government of India, and Mysore Royal Family, for somebody who doesn't know this one. And it's 100 plus years old institution, just adjacent to the, this institution here. And founder's mandate was to see whether can design original investigations in all branches of learning and to utilize for the benefit of India. I think that's something which was there. And today, you know, it's changing through various profiles to be the center of excellence on various aspects with respect to it. Contains about 42 departments cutting across various disciplines on engineering. And I think we also look at a large number of students graduating every year, about 400 PhDs. Just to give you a glimpse about the institution. The background to this talk is, I think Professor J. Srinivasan has already laid down why it is important and what is happening, why this issue has arisen and what needs to be done. And to that extent, I think he also brought about certain aspects to be really looked at. Renewables can contribute in terms of decarbonization of this sector. And what are those sectors we need really look at? And which also calls for new processes towards improving efficiencies and various aspects related to how can we reduce the carbon footprint. I think this is something which probably we can touch upon. And see, once we say energy means many a times it's being looked at, it is only electricity, but there are various other things. I would like to take you through some of those aspects so that you will be able to appreciate that one. Heat and power is something which we use hydrocarbon fuels left, right, and center across all disciplines. And we know transport, both land, sea, and air, consumes huge amount of hydrocarbons. And again, as J. Srinivasan also brought about, the so-called new chemicals which have also come in, they are also being a derivative of a typical hydrocarbon fuels. And use of these results in CO2 and H2O, and some of these things, I think, very, very eminently being brought about how does it impact and what happens to the climate change. This is just to give you some bit of indications. When we look at the primary energy supply, that means completely all the energy requirement, you still will look at the contribution from fossil fuel is fairly large. This contribution from renewables, this is across the globe, is just 15%. And when we really look at the energy source which comes from electricity generation, again, this is where you see a significant amount coming from nuclear, and renewable contribute quite a bit with respect to the electrical component of this. And the other thing which is also very, very important is when you really look at heat, which is very majorly required probably for industrial purposes. And if you really look at across the globe, in cold countries, probably you also need it for space heating. Quite a bit of that happens. And recent war clearly shows that people who depend on fossil fuel also were seriously affected too. And the renewable contribute a very, very small fraction in this one. And if you try to really look at in the transport sector, it's just majorly fossil fuel, except maybe some small contributions comes through various channels with respect to maybe when we really look at electrification of transport, we still have to really see how much of that electricity comes through renewable and kind of thing. But I think that's something which is slowly happening to become more and more green. Gross final energy consumption, wherein if you really look at within renewables, very little is spoken about another resource which is required for any mankind to sustain is you need to grow grains to feed the people, and residues are available. I think if they are not treated, it would emit CO2 at any cost. There's just no way that you can, except the timescales can be different. And to that extent, I think a large fraction of that is being looked at, about 12% coming from the biomass. And there are also projections if the approach towards achieving net zero is to be there. Some projections we made. biomass can make a very, very big impact in terms of its share in the overall scenario. I think this is where not much has been looked at, maybe in this country, and there are countries which really utilize that resource which is going to be available as a residue which needs to be treated very effectively, they have been able to use. And if you come back to India itself, you can see the kind of mobility and the carbon emissions which are there. They are quite a bit in various transport sectors, which is very, very clear, and very little which is being looked at. Maybe when we really look at CO2 emissions in the power sector, it is quite significant. That means we need to really address some of these things if you want to get completely mitigation, which may not happen. But I think wherever it is possible, this is where I think carbon capture can be really looked at, but I think it's also very, very important to address that it has to be cost effective. There are solutions available, but they are very, very expensive in terms of capture and utilization as on date. And these are industries which need significant amount of effort, wherein people have been attempting to do decarbonization of iron, steel, and cement. I think this is one sector wherein India can really look at. And you must have heard quite a bit happening in the transport sector. And building, yes, it's being considered, but I think not much is getting into the building sector. Maybe some of those things should really look at. And within the entire carbon sink, you can see that coal, oil-based is one, wherein for the power industries, again, you can see iron and steel, cement take quite a bit. And there are refineries where you have entire thing with respect to the fossil fuel. And agriculture also does emit some things. Maybe people have been looking at even growing rice can emit CH4. I think these are things being looked at. And transport sector contributes about 10% of the entire emissions. People have been attempting to see whether this can be addressed very easily. What I'm going to do right now is what are the various attempts which people have been able to look at in terms of decarbonization, renewable energy like what was mentioned, improving. I mean, this is another area which becomes very, very important for us to realize how we will be able to really reduce the carbon footprint by improving the efficiencies of devices. I think many of them have been taken care through certain processes which are there on devices, saying that if you go to BIS, they say it's a 5-star rating. So that there is efficiency improvement there, but I think this is something which is happening. Electrification being looked at, but I think we cannot completely avoid in a country like India away from the fossil fuel. We need to really look at this, as I mentioned, and this is gaining some importance over the last decade plus, and at the end, I think this is something which we need to really look at circular economy so that you will be able to recycle and try to utilize that one. This is the mantra which is going on across various, I should say, policy-making groups to look at what can be done. I should just give you some example in terms of how this initiatives got triggered within the institute campus. I'm going to be a little more technical to give an example how engineers have contributed to the disaster and how they can also contribute towards the betterment of this one. I think some example is here. Because of the 70s oil crisis wherein diesel got maybe into an issue for supply chain, the entire think tank on the campus start looking at, can there be a so-called another alternative to replace diesel which goes into our diesel pump sets. We lift a lot of water for so-called irrigation, and if that crisis again arises, then our agriculture sector will be seriously affected. Is there a thought process? Is there something which we can do? And that's where some concept got initiated, and this is where application of science and technology to rural areas, one cell got initiated. And basically today we have been talking about so-called sustainability across all disciplines. You name anything, you prefix with sustainability, and we are looking at that mode. And this was really looked at as, can we use local materials to meet local needs? I think now we have a problem statement, a diesel engine which lifts water, 5 horsepower diesel engine lifts water for irrigation. Can we have some solution to see whether using local materials in a given environment, can we really replace that? I think that's the entire research started off looking into that one. And this was not a new concept altogether. This led into now today various technologies which has been developed. I'll just touch upon one or two key things wherein sometimes maybe in the 90s when we started off this, when we matured this technology to go into the field, probably it may not have been ripe. But with the decarbonizations coming in and climate change coming in, probably I think we can revisit those technologies to see how we'll be able to service the country. I think this is something which we can really look at. And when we really look at what is available as a residue in the country, this is the surplus material available which is equivalent of 70 million tons. This is not small amount. It's a huge amount of residues which are available. Part of it may be utilized for some applications, but the whole lot is not an organized sector as of now. And unfortunately, the country, as Professor J. Srinivasan also mentioned, the policy paralysis on biomass was significant. It did not really support the cause as much as it should have done, being agro-based economy. Like what it did with other renewables, there was a stepmotherly treatment for biomass also at that point of time. How is this going to be environmentally better than maybe the options which have been available to mankind? I think you have biomass which will emit CO2. It's also a hydrocarbon. It's a complex CHO. We will just get into that one. It's a CHO complex. When you go through a conversion process, finally any C will become CO2, H will become H2O. That process is what we have been looking at. Fortunately, nature is there for us. Solar energy is available. Through photosynthesis, you fix back the same CO2. And if we follow a certain cycle, probably your net emissions are going to be zero, and it is a carbon neutral technology. And I can also show you that this technology can also become carbon negative, provided you pay attention to a few things as we move forward. And if biomass is available, it could be a range of agro residue to forest residues and any other industrial waste which come out as a part of CHO complex. There are two major processes. I think one process which you are conventionally aware is the biogas. You must have heard of this across, maybe these days, even the newspaper article carries, or there are so many other things which happen on this one. This is a biochemical process which the microbes really react with the so-called CHO complex. Under controlled conditions, it can get you a fuel value like methane, and with that you will be able to generate a range of things which people are trying to see whether it can get mitigated, to see whether we can offset certain fossil fuels using these sources. This technology has been there, but I think it never got nurtured the way it should have got. Now with several policy programs which are in place, people have been looking at can something happen. One major program which probably you would have seen in the newspaper is related to can we go through the fermentation process to convert any of these solid residues. Basically, it would address the cellulose and hemicellulose content in the biomass. I think that's something which is easily digestible, which can be converted to ethanol. I think ethanol-based fuels are going to be blended. Now it's from 5% or 7%, it's going to go to 20% shortly. I think many of these things are going to help in terms of reducing the carbon footprint in terms of the transport sector. Similarly, there is another process. One of them is what you know are aware of is a combustion, wherein you take the gas, you take the solid fuel, you burn it in such a way that the chemical energy which is available in the fuel will get converted to a thermal energy which you will be able to utilize for downstream process, either steam generation or heat utilization for various other purposes. There is another process wherein you can also do a bit of controlled process wherein the chemical energy which is available in the solid can be captured as chemical energy in the gaseous species. Certain molecules can be generated. And this is what we can really do in such a way that you don't have to utilize those molecules in situ. It can also be transported to some other location. And beauty about this is carbon is available. How effectively can I use the carbon without really creating an environment imbalance? That's the beauty about having this carbon which is going to be there, which can be in the circular economy. I think I'll show you a couple of examples related to that. What as we utilize, maybe you know that any of these biomass is being used for all purposes across the globe for a range of applications, including maybe cooking, which you have seen. And most of us initially started looking at electricity to be our prime motive, because even in this country, even today, there are pockets wherein power is not available, while there are other resources which are available. Basically, many of these power generation systems were being looked at, and if you really look at in terms of efficiencies of conversion, you were looking at when you convert the solid fuel to chemical, heat energy and use it in a steam cycle, you are looking at close to about 30% efficiency. Balance 70% was not being utilized for some way or the other. And as you really look at various other downstream products, this is another very important area, biomass integrated gasification combined cycle, wherein instead of a boiler-based, a Rankine cycle, if you go into a gas turbine or a reciprocating engine of certain capacities, your efficiencies are going to improve. These are all ideal for distributed power generation, which can be utilized, but not as a centralized location because of the availability and other resources. There are other things which people have been looking at. One is the methane, what you saw, and the new thing which is coming in is the hydrogen one. I'll just touch upon this hydrogen and how important it's going to be. See, if you really look at this part of the cycle, we were all looking at extremely low efficiencies even at 10 megawatt level. If any of you go to any of the sugar industries or something, I think there is a term called cogeneration being used. People have started utilizing the effectiveness of both heat and power in a given industry so that you can really capture a large amount of energy in various requirements. Both steam is used for process requirement and electricity is also going to be used. And this has really converted many of the sugar industries to become power producers rather than sugar producers. I think that has made a change, but I think now in the recent times they are going to be very different. But if you really look at gasification and fuel cell, you must have heard of the word fuel cell these days. The cycle efficiencies are going to be very high, for which you need a gaseous species which can go into the fuel cell or a liquid which can be converted to gaseous on board. This can really operate a fuel cycle. We can get overall conversion efficiencies in excess of about 50%. I think this is what everybody is trying to look at. This will in turn say that the amount of energy input what you are trying to bring in per unit output is going to be less, so that your carbon footprint is going to be lower. Keeping this in mind, I'll just give you what could be the end use for such a process wherein you convert a solid to a gas. And here you take a solid fuel, it just converts into a gaseous species. What is a gaseous species we can really look at? It is a CHO complex which goes in. With the CHO complex, the possible chemical energy carriers could be carbon monoxide, hydrogen, and a small amount of methane, which is what is desirable. And once having done that, now you can imagine, can I use a solid fuel in an internal combustion engine while diesel tried with coal powder? But for us to really realize something to really operate a diesel engine with the kind of current status diesel engine on a gaseous fuel is a challenge. But once you have converted to this gas, you should be able to replace diesel to a tune of about 90%. I think that's a possibility today. That means if you have pushed a corner to reduce the carbon footprint, there is an option available. And at IISc, we have also looked at completely avoiding even the 10% diesel which is used for ignition. Can it be a gas engine? Definitely it can be a gas engine. I'll show you a couple of examples. That means if you want to decarbonize a given sector wherein power requirement has to be really looked at, technologies are available in such a way that you can be carbon negative at the end of the day. It's possible. And it can be used to replace low temperature. It used to be the earlier case, maybe pre-fossil fuel availability, most of the other processes were depending on this, while though it was inefficient in terms of its operation, biomass was used in some form or the other. But with time, with the fossil fuel intervention, if you go to any of the European countries, earlier most of the so-called space heating was with wood. They moved to liquid fuels or gas. Now again, they're going back to biomass through pellets. If you see, a huge amount of pellets are getting transported across the globe to Europe just to make sure that their carbon footprint can be brought down. I think this is something which is happening across the globe. And we can really look at combination of power. I'll take you some interesting examples to show what is possible in terms of decarbonization. You have a solid fuel, it goes through a reactor, and you generate a gas which is hot, and it has to be clean because we are looking at a reciprocating engine or a gas turbine. It has to be clean. I think all that process, what needs to be done, has been looked at. You take it to an engine or a gas turbine, and it's a new fuel. A lot of work has to be done with respect to research. I think most of it, as engineers, we have been able to really look at those processes today, which will result in a product which can meet the environmental standards. I think that was another challenge as you move from one to the other. There is very limited work which is done by various groups to meet our requirement, but I think it's a challenge which you can really accept it. Yes, it needed a lot of work to be done. As Professor J. Srinivasan mentioned, there was challenge and there was also a way to see how we will be able to address those challenges. I think this is something wherein you also should be excited to see that with the new challenges, there are opportunities also which come up. And these are all really high-level science which had to go into to make sure this works appreciably. As far as the technology is concerned, decarbonization, I'll just give you a very, very simple example. While Professor J. Srinivasan mentioned there is a technological intervention which is required, which also has to have some social acceptance, which also has to have political appreciation. This is an example where it was an unelectrified village which had only 40 houses. We tried to provide electricity through the biomass gasification route, and the biomass was grown in their own village. Everything, each of these villages will have a grazing land. It was grown there, and we tried to make sure that today we get very easily carried out with prepayment on everything. Wherever you go, you do a prepayment kind of situation. We reached the stage wherein we should enable the villagers to pay for services. I think this was a great challenge what we had. Social engineering had to be really looked at. And once you started providing water for irrigation, again electricity generated through the biomass which was generated locally, they were able to pay for services. Today they used to come previous day to deposit money for next day's water being pumped. And if you go back to Chanakya's Arthashastra, 1/3 the crop value can be dedicated for so-called irrigation or any other thing to do farm needs to grow. And they were paying much more than a typical urbanite was paying for electricity per unit. I think this went on very well. Their own earning was a semi-arid area. They used to grow one crop in a year. They were able to grow vegetables. Their income went up by 10 times from the same patch of land. While we were all excited with all these processes, there are again political systems which also destabilize certain things. I think we fell into one of such things, and after about a decade plus probably this was the only village which was completely on bioenergy anywhere in the world which was sustaining, but unfortunately the sustenance did not bypass the policy paralysis which was there, and we had to come out of that because of political intervention which took place. This is an example. Similarly, on the technological front, we wanted to prove what happens in the industrial setup. This was an industry wherein they had an access to coconut shells, which is available there. The entrepreneur wanted to see that, I want to set up a business wherein I don't have to market anything every day. Can you really look at a product which can be sold to the end user on a continuous basis? This was an electricity, he went into a PPA with ESCOM in Tamil Nadu. This was a power generation plant wherein as the technology was growing, I'm just trying to give examples in terms of carbonization, decarbonization which can take place. Completely 1 megawatt power generation, fully with biomass. I think it is one of those icons across the globe which really stood in terms of doing about 40,000 hours. Again, policy did not enable them to do a long duration runs, and beyond this continues to operate. I think this is where there was a game changer which occurred. Engine manufacturers started giving guarantees and warranties on the engine, because this is all first movers challenges what you have to face. But I think these challenges were very, very encouraging to see how when you're pushed to a corner, you will be able to really develop technologies which can meet the challenge. And this is what is the technology all about. You have a system wherein you generate the gas. It has to be clean as it can go to a internal combustion engine. That was a challenge across the globe. And we had slightly other disadvantage compared to several groups across the globe, people working. Most of them were looking at biomass means it is wood. India being what it is, it's an agro-based economy. You need to really look at various other residues. This was again a scientific challenge which we need to look at. We can discuss about the science separately, but I think to put things together to make sure that you have a product which can meet the market demand. There was science, there was engineering, and the manufacturing challenges. I think one has been able to overcome to look at these plants were being really put into the field through licensing mechanisms wherein the license were able to give guarantees of about 7,000, 7,500 hours like any other power plant at the end use. That means the complete engineering package had to be put together. I also should claim that here it was one of those unique multi-fuel capabilities which is a requirement for a country like India. And proudly we have been able to transfer technology across the globe to GE in the US, to Europe, to Japan. I think this has made the game changer in terms of the technology which can really go back to the, I should say, end user to solve the so-called issues related to liquid fuels or gaseous fuels. Similarly, I think one has done several things. This was a very interesting proposal wherein Hindustan pencils, you've been using Apsara pencils and various other things. Many of them are manufactured using wood as a fuel. And in fact, these guys were looking at how to utilize the sawdust which is going to be generated for a value-added product. I think this is where they went to Hanover Fair in Europe. By the time we had established our footprints in Europe, I think they had a stall in Hanover Fair. They said, we are getting technology from India, why don't you go talk to them? I think that's how 2 of their factories were completely operational with the sawdust what they were generating locally within their premises. I think these are some examples which are there. Maybe it did not make much, I should say, stride in the country at that point of time. With the new thinking on climate change and the kind of decarbonization which is being looked at, probably it's time that we can revisit them. And there are examples wherein I have not discussed, we have been able to replace oil in all industrial sectors. You name heat treatment, you name high temperature, you name biscuit manufacturing. I mean, a range of applications can be addressed by simply using the residues which are going to be available, which is going to be carbon neutral or carbon negative. And similar, we had opportunities to put this package across the globe, maybe about a megawatt power generation in Thailand. And this is our technology transfer in Japan. This is the GE manufactured system which went into San Francisco. And we also did islanded mode of electrification on various programs. This is just to give a glimpse. Because of 70s oil crisis, we started looking at a solution. I think today we have a solution wherein we can take it to a range of applications. For example, agricultural sector, typically government, this again policy intervention has to take place. Government spends close to about 30,000 rupees per farmer on various subsidies which go in. In fact, I had occasion to talk to the union ministers on this. They generally agree upon the thought philosophy. What is being said is, why don't you put a distributed power generation, because it's going to be agro-based economy, agricultural residues will be available, so that you will be, if there is surplus power you put, grid will become a backup. While they agree upon on these things, again the political compulsions of giving free electricity and other things which we don't have to discuss here. And there are many other solutions which can be really looked at as a distributed power generation system. And typically the efficiencies and the environmental standards can be easily met with to look at, you have seen that this can really meet even the European emission standards which has been set together. I think these are some things which I thought I should just bring it to that. Another intervention which we did, which had a very, very major impact, though it is simply a chula, it can make a big impact. British Petroleum was looking at intervening into the so-called rural economy through their own fuel, the fossil fuel, and they were looking at, can we look at, it was not exactly decarbonizing, can we reduce the fossil fuel footprint which goes into each of these things? They were looking at, can we do something with biomass? They came to us saying that you have been working on gasification, can we really look at some small scale activities? Then we had developed another device based on similar principles on gas, based on the thing. And I should say that this was something close to about 50% efficiency. You look at LPG stove is close to about 70%, kerosene is about 60, 65. Most of the wood burning stoves are less than 10% efficiency. Apart from the loss in efficiency, the emissions and various other things can also be a contributor. This, at some point of time, had really contributed towards reducing about 10 tons of LPG every day. That's not a small amount, but I think scale has to take place and various other facilities has to happen. But it has been transferred to industries, and industries are looking at this very cycle. And only thing is, maybe this requires a complete cycle involvement right from R&D to that, because as institutions, we do not have a buffer zone between academia and the industry. I think that has to be bridged. I think Institute made possible such a thing to happen. The impact of what had happened was, I should say that provide technology leadership across the globe. And we were saving about 50 tons of oil every day. I had to use because it is no more continuing. Probably in the times to come, I think things will happen much more than that. And this has also resulted in putting more than about 500 crores worth of private money into the entire operations. There is also a business angle to this. I just wanted to bring it to your attention. Maybe I'll move the subject. This can also contribute towards decarbonization on various sectors. But one of the major things which the government of India and various globally people have been talking about, can we really look at green hydrogen? I think there was no concept of greenness until very recently because many people started looking at that one. And hydrogen in the country, we use about 6 million tons. Majority of that goes into refining and ammonia manufacturing and large-scale activities which take away this one. And currently, entire thing is being generated using either naphtha, which is a hydrocarbon, or methane or CNG or LNG, whatever you can call it. These are all the ones which contribute. And if you really want to look at the chemistry, what actually happens, you take methane, you can really do the catalytic conversion process. And if you do an ideal, say a magical reactor, you require roughly 2 kgs of methane for every kg of hydrogen to be produced. I think that's something. But in an actual situation, you need about 250 grams, that is 4 kgs for every kg of hydrogen you produce. That means once you produce this one, you are putting about 10 kgs of CO2 into the atmosphere. Every kg of hydrogen, all refineries, all ammonia manufacturing groups are currently utilizing naphtha or CNG. And there is no work on transport sector which has taken place on hydrogen as of now, except that a few trials here and there. I think government has been really looking at what needs to be done. Now here I will introduce biomass in terms of its chemical formulation. It's a very, very simple high school chemistry. You have so-called biomass which contains about 50 grams of 50% carbon. And this is the beauty here. There's already carbon available in nature. Can we effectively utilize that one? That's something which we can really do. And it contains about only 6 percentage of weight percentage of hydrogen. And balance is that. And nature has really created a beautiful structure in such a way that the CHO complex is roughly same across all residues. That is the beauty, except for ash content. Across all residues, you have a CHO being same. Now with biomass, you have about 65 grams of hydrogen per kg of biomass, which I also told about 250 grams is required per kg of through methane. And when you really look at green hydrogen, people have been talking about electrolysis using electricity from either solar or wind, trying to generate, and you have about 110 grams of hydrogen for every kg of so-called water you go through the electrolysis process. And if you extend the same chemistry what you did for the fossil fuel methane to biomass, if I take a magical reactor, I should be able to generate about 150 grams of hydrogen for every kg of biomass. Let us just now concentrate. Water is there here. Water can produce roughly about 110 grams. There is also carbon here, which can also contribute if you effectively utilize the carbon, because methane is again doing the same thing. It has carbon, it has hydrogen. And in the air gasification mode, what you saw the technology so far, we can extract about 40 to 45 grams of hydrogen for every kg of the fuel what you put in. This is just to show that the engineering challenges were, if you take this, which is a well-established technology, probably many groups across the globe have been looking at, while still there are USPs on what has happened at IISc. But the challenge was, if you take this as a fuel, will you be able to really get hydrogen, which is going to be economical again? Finally, the sustainability will have another pillar called economics, which will drive the thing. And we had to really look at the chemistry. This is again the innovation came in. You eliminate nitrogen, you bring in, and again you have created an environment wherein you can cross about 100 grams of hydrogen per kg, every kg of biomass. Today we can really look at about 100 plus grams of thing. That means what we did on air gasification, we moved to oxy-steam gasification. You get a composition which is close to about 50% hydrogen. This is like something similar to what a steam methane reformer can do. Whatever a CH4 with catalytic bed was doing, we have been able to go closer to such a process. And having done that, we were trying to see, and this is the thing which is there. The entire system is where the entire gasification is separated, and we can get pure hydrogen which can go to fuel cell. And this is where we are trying to look at, can it become a biorefinery? Can you get methanol? Can you get ethanol? Can you get ammonia? Sustained aviation? I think these are all the avenues right now which are available for you to tap to see whether, and again there are challenges here which needs to be addressed. Currently what we are trying to look at is, can you really do exactly what a so-called fossil fuel sector is doing, wherein can you really bring everything close to what a fossil, for example, ammonia is a Haber process. Can you bring your gas quality to meet the Haber process? We should be able to do that, and that's something which is happening along this direction. And the beauty here is, if you can get these molecules, we will be able to substitute what currently the so-called fossil fuel sector is trying to do. That means, can we do a bit of, I should say, a greenness in everything what is going to go as a hydrogen or a molecule of fossil fuel substituted in the transport sector. I think these things can definitely be done. And this is just to show that, yes, you have process control wherein you will be able to really control most of the parameters to get whatever you want, like a typical steam methane reformer. And the challenge in terms of the quality, again, is to get purity which is 99.97 and the contaminant levels to be very, very low. I think all this has been achieved today to meet a fuel cell grade, probably one of those very, very important interventions which have taken place to generate hydrogen of a requisite quality which can go to a fuel cell. That means today if you're pushed to a corner to say that, do you have a source? And the beauty about this is it can be a 24/7. It can also become carbon negative. I think that's something which, when you can capture the CO2 which is required for end utilization, or we can sequester carbon in terms of activated carbon or downstream applications. Most of these controls are there to make sure that we can also look into another very, very serious issue. I think this is something which some of you should really look at, like plastics. You also should look at municipal solid waste. There's no easy way to handle any of those things in an environmentally benign manner. That there are a lot of scientific challenges there. That's something which this process can really look at. And when we really look at the CO2 emitted, we can say that if your carbon rotation period is 1 year, the global warming potential is very, very, it's virtually zero. If it is going to be 10 years, it's going to be just 4%. That means if you are looking at an agro residue which is close to be out a year, you are not going to create any environmental imbalance as long as you have technology and you have technical challenges which you will be able to meet the emission standards. I think that's something which has happened. We are going to set up, I don't know how many of you are following the hydrogen pathway, what the government is looking at. There are going to be motive powers, and as a part of one of these activities, we are going to set up, for a couple of buses will be operational using the hydrogen generated from biomass to see whether it's going to be in Delhi sector. People will use this one for a range of applications. And here to some extent I thought maybe I'll just switch a slightly different. And if you really look at the so-called applications wherein people have been addressed, you need pure research like Edison or inspired research by Pasteur or some of these things. But when we really want to move into this is typically called Pasteur's quadrant, but if you really want to move into products, I think we need to have an optimal mix of these two together, which is what is happening in many of the startups today. They have a certain amount of innovation, and now some other challenges which are coming in terms of making sure that can it become green in kind of situation. I think this is something which probably many of you will be able to really look at and move forward in that direction. I would like to thank my a big team there, and thank you very much for all this.
I think we have time for maybe 2 or 3 questions. Anybody has any questions?
tell me what others?
As in for hydrogen generation specifically, and you said biomass conversion for biofuels, right? So is that
See, unlike I do not want to put one against the other, each of these technologies will have its own merits. If you have a wet material, say for example market waste, probably the biological conversion would be a most ideal thing. But this part of the thermochemical doesn't distinguish between cellulose, hemicellulose or lignin. It is just treats it as a CHO complex. If I were to give you a simple example, going through the fermentation process per ton you can get, if you must have heard of ethanol quite a bit these days, you get about 220 to 240 liters. With this probably you should cross about 400 liters. That means the unutilized lignin can also contribute quite a bit for this.
Maybe one more question from the ladies, if anybody is there. Any questions? Okay, if not, let's give a round of applause to Professor Dasappa. I also invite Professor Vinoy to just give him a token of appreciation. Thank you. And his lab is only next door, so if you want, then certainly please have an appointment with Professor Dasappa, and you can certainly visit many of these things in his lab. Okay, thank you. So our next speaker for the day is Professor Goswami. He is a associate professor at the Azim Premji University in Bangalore, and his primary research, surrounds around climate change, and he has had many different hats. I would say that he has worked previously in New York in the urban city development part of it, and also, yeah. So I should. Thank you for reminding. Also, I think he's proud to be associated with ISRO as well on data modeling. So with this short introduction, let's give him a round of applause, and please do welcome, sir.
Thank you.
You can start.
All right. So, as this is a PARYAVARAN outreach event, so I made this talk for the students. So I'll mostly be talking to the students, and so have you finished your sweet? Gone, long gone? I saved mine. You know what? I'm going to give you a really, really bitter story. So I'll need the sweet because I'm going to tell you the story. It's bad luck, that you guys had it much earlier. So this is probably not new to all, right? To you, it's the chaos that we see around us, right? The increasing that we are seeing this chaos, the increasing that we are. Was debated, was challenged to some extent even now probably, but at one point when you talk the consensus or the support about it is coming stronger and stronger. It's a lot easier to talk about climate change now, and that's why we also recognize that we need to handle this crisis that we are in right now, in this mess, and so how we need to prepare ourselves through innovation to face the drastic future we are going to see. So this is a the sort of the same picture that Professor Srinivasan shown, but this is from 2022, the change of average, global temperature compared to a recent period. And this, so you can see the changes are heterogeneous. There are different increase in temperature, like a lot more when it goes to the northern hemisphere or to the southern hemisphere towards the pole. And of course, what's causing this mess? This is climate change. You all know it, right? But when it comes to India, the scenarios are a little different. Scenarios are probably not as bad compared to some of the global areas. But again, it is heterogeneous, right? So the recent synthesis report that IPCC produced, they identified few things which confirmed, or basically, it's a confirmed connection of human activities to climate change. And one thing that was pointed out from the report was that the globe as a whole, there's one number, experienced 1.1 degrees Celsius temperature increase since the last industrial era. So our models say that it's, we are going to be reaching about 1.5 degrees Celsius temperature increase in the near future, say around 2030, 2040, around that area. And the changes that we have seen since the last industrial era with about 1 degree Celsius temperature, it has caused all these widespread changes around the Earth. So all these different extremes such as heat waves, in droughts, heavy to very heavy rainfall, they are already on the rise and they expect to rise, go up even more. And India, when it comes to the climate change, it is considered as one of the hotspots, mainly because of its developing certainly a very high economic development activities, and also it's highly dense. Now, one of the things I want you to think about, if we are in this mess because of 1 degree Celsius temperature rise, what can we imagine what we are going to be if the temperature increase is going to be 1.5 degrees Celsius in the immediate next future that actually we are expecting. Now, climate change or temperature increase, it happened again and again in this Earth. But the increase that we are seeing right now is a lot more compared to some of the previous cycles. And the main reason is that this is, when we are seeing this temperature increase, we are actually talking about civilizations, one level of civilization being hit by it. And we are also the one who is actually causing it, right? So again, as I said, that 1.1 degrees Celsius global temperature change has caused so much damage to us, then try to think what 1.5 degrees Celsius increase in the next few decades is going to do to us. The globe has been warming, climate change has been happening, and we identify some of these indicators, global indicators, as an indicator of basically climate change happening. And we also talk about vital signs as an indicator of these climate changes that is happening. All right? So here, you can see in here, carbon dioxide is going up. It's at 420 parts per million. Ice sheet is going down. Global average temperature is going up. Sea level is going up. Arctic sea ice minimum action is, it's basically like decreasing every year, and oceans are warming a lot more. So before we get maybe to talk about a bit of models and all, maybe it is very important, because you guys are engineer, I'm here to talk to you guys about climate change, just so that you can find solutions. What is the most basic stuff when it comes to climate science? There are two parameters, temperature, precipitation. That's all we talk about. And those are what actually we use it as when the temperature go up, it changes the precipitation as well, and that causes the overall changes, overall destruction, overall, whatever you can say, like it caused the disruption. So when the temperature go up, right, I mean, what happens? Once something basically warms up, it expands, right? So same thing, when the temperature of the atmosphere, of the air go up, it expands. That means it can take more moisture. And when, I mean, and you probably also know that how rain happens, because the water vapor going up, and at some point it condenses, it comes back as a rain. If the air is going to have a lot more moisture, that means it's also going to have a lot more, it's also going to create a lot more rain. Only thing is, when it comes to like climate change and changing precipitation patterns, these patterns are going to be heterogeneous. So some areas are going to see less rain, some areas are going to see more rain, and some areas are going to see different patterns of rain, correct? And then again, let's, as I said, probably good to talk about what are the basic definitions when it comes to weather. It's a short-term weather pattern. Basically, short-term atmospheric conditions such as temperature, humidity, etc. You can say, how has been the weather of Bangalore this week? But when it goes to climate, we are actually talking about the weather for a much longer period. That is basically long-term weather, you can say it's a climate, right? Then when you say climate extremes, this is very important to understand, because this is what is going to have these major changes, major impacts on the humanity or on the Earth system. There are weather events which may be much longer or maybe much more higher intensity than the usual. For example, a heat wave. Right? Heat wave is a period of hot weather that remains for a long time. So that's, heat wave is one of the extremes, and sometimes you can have cold waves and drought when precipitation is going to go up. And flood can be your basically perennial flood, or it can be your flash flood, right? Now, the question is, after I define this, what is weather, climate, and climate extremes? So if we are going to know about the future, if you want to know about the future of the climate, the only way we can do is through climate projections. We're basically, running computer models and trying to simulate how the climate is going to look like. Again, these, as this is modeling, as we are talking about the future, these are going to come at a certain your uncertainty. All right. So these are important because that's the only way to look at the future climate, and it also helps the decision makers, because you can go and say, hey, this area is going to look like this, and you can think about basically, or people can think about, people in authority can think about developing policy which might address some of these changes that actually we are going to see. And of course, identify potential future risk and a percentage of future climate change, such as change in crop yield, impact on biodiversity, and the spread of disease, etc. Right? Now, climate projections also play a crucial role in international agreements on climate change. So now, how we do it in here? There are many climate models. Because these are models, those models are going to be run in their own way. I mean, they will not be proper standard. So this CMIP is called basically Climate Model Intercomparison Project. This was developed just so that these models can be run with proper, similar inputs and standardized. And then once you run it in a similar way, your uncertainties are little lower, and at the end, what you do, you basically ensemble and basically average it out. So, and then, yeah, so that's basically your CMIP. We are using CMIP 6 data in here. And we are using two emission pathways, we call it, as IPCC recognized. One is mid-emission pathways, basically, your responsible issues of fossil fuel. And the high emission when it's like, basically when the scenario when nobody cares, right? High emission. So, as I said, these SSPs are 5 storylines or scenarios that describe the future development of society, right? As identified by IPCC. If you just want to remember on it, when you say SSP1, sustainability, SSP2, middle of the road, SSP3, regional rivalry, SSP4, inequality, and SSP5, basically, fossil fuel development. Now, as I've given you this background, so what we are doing, we are actually taking this CMIP 6 model data, and we are creating future scenarios for India, and we are doing it, trying to create scenarios for a district, different districts. It comes with, when you run a model, if your area is much larger, or if you're running at a coarser resolution, your results are probably going to be more accurate compared to when you run it for a finer spatial resolution. So with districts, there will be like uncertainties, but there is a value to produce these results because this can address to specific areas. Now, the question is, once, I'll just show you, some glimpses of what we are seeing on here. And as we run this, the question is, whether how blurred our future is going to be. Is it going to be great, which of course is probably not going to be good. And then if it is bad, how bad it is, right? So from our data, from our analysis, we see that India as a whole, if we think about India as one number, will reach, the annual maximum temperature will reach 1.5 degree or, 1.5 degree by 2040, around basically near about 2050. And when you talk about summer maximum temperature, the country, the average value for a country is going to reach 1.5 by about mid-2030. So it's actually pretty scary. Then I'm talking about just one number for India. But changes are heterogeneous, so there is a lot more to it to look at than just looking at the number. So if we look at India, again those SSP 245, SSP 585, when I say it's a middle of the road scenario, and basically that high emission scenarios. You can see how different parts of India are going to experience, temperature change gradients, right? If you look at the Himalayas, Himalayan states are going to be a lot more warmer, right? And it seems like going to West Bengal and Bihar might be a good idea now, right? You look at that. And then if you look at like summer is going to be really, really warm in the Himalayan states and also across the western states, right? So from analysis, we said 151 districts are going to experience, 1 degree or more temperature increase for the annual. And then there are the range of things. I just want to show you a table. As you can see, as I said, the Himalayan states are going to be pretty badly affected when it comes to maximum temperature change, right? Then the point is, as Professor Srinivasan was mentioning, every degree matters when it comes to temperature change, correct? And from the IPCC, what I said, from the IPCC report, what they say, that the world as on average, experienced 1.1 degree temperature change since the industrial era. Thinking about having a 1.5 degree or more in the next few decades, in India, you can think about how we might actually face, what you might run into, right? As I said, with temperature increase, precipitation patterns also change, right? When you look at the precipitation across India, it becomes really, really interesting. So in India, we have two monsoons. One is southwest monsoon. The second one is the northeast monsoon. Right? Northeast monsoon, the winter monsoon that normally experienced in the like your southern states. Southeast monsoon, the monsoon that goes across the country, where most of the country is like rain and precipitation. Correct? Now, if you think about it, if you look at like India, this is annual, this is southwest, this is northeast. These drier states, they're going to have about 40 to 50% increase in precipitation. Correct? What does it mean? When the dry states, they have their agriculture, right? They have their pattern. Then when you have this much rain, like this much more rain in there, so that's going to have a huge impact on the agriculture. Correct? And then because these are drier states, their vegetation cover is going to be a lot less. So you are also talking about soil erosion. That means the fertile layer is going to be going to be removed from there. Then how do you deal with that? And then think about these, and those in the northeast, these Himalayan states and the northeast, they are actually going to be seeing a lot less rain. And I don't think I'm actually showing it here. But when we are working with data for the northeast, northeast is going to be drier in total, but the hydrological extremes, they one-day precipitation. Basically, you can say how much rain you get in 3-day spell, 5-day spells. Those are on a rise in the northeast. They have been on a rise, and they are actually projected to be on the rise. So in one case, whole area is getting less rain, and whatever rain is coming in, it's just being like happening in smaller spells, right? So that increases the disasters and also a huge impact on the crop yield. Again, when it comes to, there's some of the actually glimpses that I'm saying. Think about it in Jamnagar in Gujarat having 35% more rain, annual rain, right? And then, average annual, southwest 30%, and in the northeast it's about 60% more rain on that. So then how do you deal with it? And these are challenges, but these are also opportunities. So so then if you have this much rain, or this much more rain, which is going to impact the agriculture, then what kind of solution you can think about? Can you think about like an information system? Can you think about something else? Correct? And another thing I wanted to actually talk about, which is we are starting to talk about it a lot more now compared to earlier times. If you combine, as I said, when temperature goes up, your evaporation go up, right? Air is able to hold more moisture. So your humidity goes up. So you combine humidity and temperature, then you can compute a number called wet bulb temperature. That wet bulb temperature is actually an indicator of the thermal comfort, right? So on an average, about 31 degrees is considered as, if wet bulb temperature is 31 degrees Celsius, it's considered as highly harmful. And I think about 35, I'm not sure, about 35, it depends on the area. So 35 can be fatal. Basically, if you're exposed to that much temperature, in few hours, people are going to die. And it doesn't have to be outside. Even if it is, somebody is staying inside the house, right? Then people are going to have huge health, impact. Then the question is, if you think about it, and so this is one. Okay, let me show you. Say maybe this. Yeah. Say if you are going to have the coastal states having much higher wet bulb temperature, then you think about the overall population. Because in India, about half of the working population, they work outside. And I mean, this year only, right, we have had scenarios where in Northeast, schools were closed for a week or two because it was so hot. And Northeast, because at that point, I think even the rain was also there. Overall your wet bulb temperature was a lot higher. In Kerala, the shifts, your working shift were, I think they gave like a 3-hour break in between for a lunch break, just so that people can start early and have a break and, basically like work a little later. So these are like immediate challenges coming from climate change. Now, how do you solve it? Correct? On one case, if you think about people who can afford electricity or who can afford air conditioner and fans and all, people will be using them a lot. That means it's a huge pressure on the energy sector. Then you think about people who actually cannot afford air conditioner or even a fan, live in much, much smaller houses. Can you design something which is actually going to help this situation? Correct? So, even though trying to talk about the bitter side of climate change or what's coming up, as an engineer, I really want you guys to think about what might, or how we can think about it from a solution perspective. That's where the challenge is, that's actually the percentage. I'll actually finish up giving an example in here. So these are, as you might remember, the Himalayan states are going to get a lot warmer, right? Then Himalayan states are also very vulnerable when it comes to disasters. And this year we have seen a lot of those examples from Himachal and all. Landslides are going up, your flash floods are, it's happening in whatever time, right? And we're talking about a lot of people who are living in there, about 76 million people, right? And if I just look at the land surface temperature trend for this area for the last 20 years, you can see it's already warming up a lot, like the whole area, right? And the projection is it's also going to go like a lot warmer. Then the projection, that we see from here, it's also going to get a lot more rain, correct? So in those areas, think about Ladakh, right? Ladakh is going to have a lot more temperature increase and a lot more rain. What is going to lead to? We're talking about barren lands, right? So you're talking about a lot more disaster. It's going to have direct impact on the people living in there, whatever traditional agriculture practice they have on that, and a huge impact on the tourism industry, and also the entire logistic chain, correct? So it's not that, we have a solution to this, but if we get to see this sort of a picture, then we can maybe start having discussion, thinking about it, and, of course, now we can research anything using Google. So something that you should actually start thinking, what can be done on this? And when I talk about these Himalayan states, particularly they are extremely important because these areas are sitting on something called permafrost, which hasn't been studied at all, like almost none studies being done. So that's why we do not know the state of permafrost in these Himalayan states. And permafrost again, this is something I work a lot in European Arctic and North American Arctic. Over there, when you see permafrost, you actually find permafrost right below the ground because it's way up. I'm talking about 71 degrees to like 75 degree northern latitude. So what it is actually frozen soil. By definition, whenever you say any ground which is frozen continuously for 2 years or more, that ground is called permafrost ground. Because of the very cold nature, because of short growing circle in much higher latitude, plants do not get time to decompose. So they just stay as it is. Basically, over thousands and thousands of years, all these layers have built up, and that ground is formed, which is like a block of ice. It's not really ice. Block of mixture of ice and all this organic stuff, because it's not decomposed yet. And in between, water get trapped, and then you also get this kind of things called ice wedges. Basically, blocks of ice, they're trapped between all these permafrost soil. Everything is frozen, right? Now think about if this ground starts becoming warmer and warmer, and rain, it's, when you have a lot more rain, it's actually warm, right? So a lot more rain, a lot more increase of temperature, then what is going to happen to this ground? This ground is going to slowly going to sink in, right? And if this ground has a lot of these ice wedges, if that ice wedge thaws or melts, I'm going to call permafrost as thawing and ice wedge as melting because it's just ice. If that ice wedge goes away, then that whole ground is going to just collapse, right? So when it comes to permafrost degradation, there are two things we call. We call it press and pulse. Press is when it slowly sinks in, and pulse is when something happens, like this big piece of ice is going to go away, so the whole ground is going to split apart. So it's like pulse, right? So, and when it comes to bigger scale degradation, these sort of things can happen, and the overall impact is can be something like that on the overall landscape, right? So now I combine climate change and permafrost just as an example to think about what could be the future scenario for the Himalayas if we bring in that component as well, right? So again, these are some of the stuff that actually we tried to do, and something that I want to actually show in here. We're looking at a very small area near Leh, and if you see from the left-hand side, it's all warming up in the last 20 years. And it's not possible for you guys to see because the scale is not properly done, but there are areas in here which have seen 4 centimeter per year depression on that, right? And when it goes to permafrost degradation, so this is what it can have as a direct impact on the infrastructure and on the population as well. So, Josim, what happened? We don't know whether it's permafrost or not, right? Because we haven't really studied it. So again, think about it. What we are going to see in terms of the projected temperature increase and the associated changes in precipitation and its different derivatives. What it's going to lead us to from our recent experience that we have, and then we need to start thinking about how blurred is our future. But remember, we have to accept the reality. This is our India, and we are envisioning a difficult future for us. So as engineers, what can you do to help? So make say through innovation, can you solve this problem? That's what actually I want to end. Thank you. And it can be any question, because I did not direct my talk to I just wanted to show you that there is a bad future.
Some of these changes which you have predicted across India, is it mainly because the temperature change or deforestation?
So the changes that I showed in here, that is because of temperature change. But then I'll connect to what you are asking. If you think about deforestation, right? When you remove the forest of an area, that completely changes the overall ecosystem and this energy exchange. That expedites a lot of these changes. So,
has any correlation studies been done?
Yes, sir. Yeah, that's a very interesting area. But then again, I have to go to from the data side of things, right? When the problem is, when we have the forest cover maps of India for the last, say, 20, 30 years, I don't know for how many years, because of the method that we adopt, those maps may not be quite accurate. So that's why it takes a lot of time to even look at, like, change in terms of land cover change. We do not have that sort of a very high resolution data or data product which people can use. And to, it's an basically it's a accepted understanding. Then when you remove forests, it is going to most probably going to increase your temperature, and that has something to do with your precipitation and all. But that information at user level is not open to, say, students and public. So that's where you're missing.
No, but as you know that the El Nino and southern oscillation has a much greater impact on our monsoon than the local temperature variation.
That is correct. But I was looking at the, if I'm not wrong, if we look at these ENSO events, the amplitudes are also increasing. And yeah, so that's also, I don't know why that's actually like going up. But yes, so this was based on temperature mostly on this.
Any other questions? You need to come in front. If you can come in front, it'll be easier for me. No, that's fine.
You talked about the effect on the Himalayas.
Yes, sir.
The permafrost sinking down, right? And
yes, sir, yeah.
Subsequent effects on the buildings and other things. But what about this high precipitation and increased rainfall and the water level in the sea level rising? We have not talked about, because we have a huge coast in India. What is the likely effect that may happen if the sea level rising?
So sea level rise probably has more to do with temperature increase because of the specific heat, when the sea gets warmer, it's going to get expanded. And that's going to give, that's why we talk about this increasing, say, cyclone patterns, like frequency, and then sea level rise, that 1 feet of rise, how this is going to, say, wash out some of the coastal areas. So studies going on, even we are doing, some of the studies out there. But again, so that's not quite definitively, I can say that, this is exactly what's going to happen on this. But we know that, this frequency of these cyclones are increasing, and then, again, when you talk about one disaster like that, you're talking about the impact on the ground and the overall economy and the society, right? So, yeah.
Hello. Sir, you're asking us to be the change maker, and also you talked about how we using private vehicles and overpopulation, these are one of the factors for the increase in temperature, right? But sir, don't you think we should treat the root cause? Why are people buying more private vehicles? In Bangalore, you can think about the city planning, right? The buses are not organized. If
maybe I should give the question to Sar. He's a lot I mean, look, I have a car. Yeah, it has come from my personal view. I have a car. I don't drive it more than 3-4 kilometers from beyond, around that circle. Rest I use basically Bangalore city bus. Maybe change the lifestyle. I don't know why people are buying more cars. I am not.
I mean, of course, we also have to change, but also it's also a problem at the institutional level. If the metro system was more connected, if I talk from personal experience, before I bought a bike, I had to take 5 buses to reach college. And also the bus system is also unreliable. So if the buses were more reliable, if I could only take 1 or 2 buses and reach my college, I would rather not buy a bike. So,
no, I agree, but I think we're talking about societal change in here, change in attitude. And when we are thinking, or when you're talking like that, we should probably first ask ourselves, have we changed? Right? So instead of immediately putting a finger in the institution, you should think about, have you changed? Have you made your friends change? Right? That's the start. If everybody does that, think about the power of that ripple effect. Right? If you can make that impact, right? Talk to your friends, change everybody, right? then tomorrow you come and talk to me. You can go with that group, you can talk to the city, you can change many things, right? So you have to think about it. That's an activism, which I don't quite support, but activism, if you do it in a positive way, it can do a lot of things. Yeah?
Sir?
Yes.
Sir, actually I wanted to ask one thing.
Yeah.
Very crucially, I wanted to ask, if you see in India, currently in India,
Yeah.
there are actually many autos in India, many auto drivers in India. And what happened is, these autos, I don't know, like, if it's equipped with any, like, something that can reduce the pollution, because currently in India there are many bikes, there are many cars, and there are many autos. So actually, to reduce climate change and to reduce temperature, normally what you would do is you would suggest to reduce the number of cars you own and all that. But these auto drivers, they depend on their autos to make a living for themselves. So what initiative, what would you suggest? How do you...
See, I mean, I'm very happy that actually you found their angle, because auto drivers are living on their auto, or their family living on their auto. That is extremely important. When it comes to Indian society, it's a very complex system, right? You cannot close down all the autos tomorrow, correct? Because that really is going to have an impact on their occupation, right? So again, I mean, I'm not the authority to speak on something like this, but my question would be, can we change all these autos to some renewable energy like type, right? Then again, when it comes to like electric energy, right? If we are going to turn everything into electric, but are we actually going to end up burning more coal? Correct? So these are very, I mean, then, you know, like nuclear can be a very clean energy source, but what about the disaster that might happen, right? So that's why it is extremely important to have this discourse, continue this conversation, debate, ask questions. It has to be at a very personal, at a very ground level. Then only you can find the right solutions. Yeah.
Thank you. So I think from INAE side, I think we had debated on what should be the first theme for the first event. But I think I'm sure that next year, Professor Gopal Krishna, you had suggesting that we should have sustainable transportation as probably the theme for the next year.
Yeah.
So I request those of you who have questions on transportation, then you should certainly come back next year into the same hall and we'll probably take some questions. But just I had one question for the two speakers, Professor J. Srinivasan and yourself is, I think climate change has its own good effects. It's bringing more rain, so we should have more fresh water.
Yeah, so actually in some cold places, in some cold places, certain political leaders are becoming very happy because climate change is going to open up a lot more land for agriculture.
So it'll solve our water problem in Bangalore as well, I think.
See, that's the point. I mean, this is, yeah, it's bringing in more rain, but is the rain spread out? No. I mean, it's like when it comes to Indian scenario, rains, what we are seeing, it's going to be like sporadic, but in big, like, you know, it's going to be like forceful in small chunks. That is going to, like, you know, create a lot more problem. Yes, so this month, Sar can actually say more. But it's the anomaly that we talk about, because Bangalore this month, sir, is what, 30% less, no, compared to the normal. The precipitation, like Bangalore, I think last month has seen about 30% less precipitation, or something like that, right?
That is part of climate change.
Sir?
Climate change. That is very true.
Yeah. No. That's definitely, that's an anomaly. Then I got another thing, right? You know, because again, point is, we are from our center, we're organizing a data journalism workshop across India, right? So one of the, like we go around India and you work with the journalists as a cohort. One thing we have been trying to tell them that not everything is climate change, right? I don't have the number. Google it.
No, I think we have become too deterministic. You talk to anybody living in rural areas, they know year-to-year variations are there. They learn to live within it. We have become arrogant. We want everything to be exactly.
Yes.
It's not possible. Variability in rainfall is natural. Okay. And most of the climate models he talked about don't correctly reproduce the present rainfall. So I don't know what they'll predict for the future. Okay, most models cannot correctly reproduce rainfall over Bangalore because it's too small an area, has a lot of land use changes, which the model does not have. Okay, so if you ask me why it didn't rain much in Bangalore, answer is I don't know. This is a pattern of natural variability that exists in all parts of India. We have to live with it up to a point. Okay? Yeah, 50 years from now, there will be large changes, which is due to climate change. But year to year, we cannot attribute anything to anything. It is convenient to blame somebody else for what's happening. But as you correctly pointed out, first ask yourself, what is your water use pattern? How are you taking care of it? Rather than try to blame somebody else. Okay?
Yeah, that's correct. I mean, yeah, I just want to connect to this. First thing is always how we are, our personal habits and behavior, right? Then how responsible we are as an individual. If we are responsible, if I'm responsible, can I influence my friend circle to change the way I want it? I mean, because I know that's the way to go. And then can we have this ripple effect? That's what we want to see. In climate change, we cannot give a direct answer because it's pretty uncertain, right? Even techniques are uncertain that we know the result that produce. Is the community sense that we have to build first to make the changes at our level, right? I mean, climate change is long term, but what about the houses that we are building, like going crazy in these cities, correct? That's not climate change, that's us doing it. But that's going to have a huge impact because of this overall, that's going to come back at us. So thank you very much.
Thank you. Let's give Professor Goswami a round of applause and invite Professor Jagdish to just give him a token of appreciation from Ramaya's University. Thank you. So we'll break for lunch. Let's have some water and then we'll continue the discussion at 1:30. But I think ma'am will make an announcement. But this also means that we have now, with the permission from INAE members, that we'll have sustainable transportation as a theme for next year. Is that okay? You would like to say something on that? Okay, all right. Thank you. So,
thank you I think we have to thank Professor Gopal Krishna, Professor Pramod, and Dr. Atre, of course, for arranging such motivational talks in the morning. I think most of our students have benefited highly from that. We will now break for lunch, and we will join at 1:40 for the student presentations. Thank you once again.